Okay, so hello everyone. Welcome to our second day of the second European persona user workshop. My name is Ivana Golub. I work for PSNC 100% on the GÉANT project, and my role in the project is a co-leader of Network Technologies and Services Development Work Package. And I'm also representing GÉANT in the perfSONAR project as the steering committee member. So as yesterday, the agenda and the presentations of our workshop are on our wiki, and the link is posted in the chat and is also available here on this slide. This workshop is recorded and the video will be made available on the YouTube, we hope very soon after this workshop is finished. We would like to ask you to mute when you are not speaking, and it would be great if you can, of course, switch your camera on so that we have a little bit more feeling that we are all together participating in the same event, if unfortunately we cannot be in the same place. Each of the sessions have their own Q&A session. So you are welcome to post any of your comments or questions in the chat, or wait for this Q&A session, and we hope that then will be more time to address all of the questions. So as yesterday, today we have 3 sessions. And the only difference being is that yesterday we were focusing more on listening from users, their experience in installing and using persona, some challenges and difficulties that they met along the way. But today we will have the presentations from our developers from all 6 partners that are currently in the project. We will start with the presentation from Szymon about performance management platform service update. And then we will have the presentation from Magnus and Christopher from SUNET. We will talk about CNaaS deployment and pscheduler.txt plugin development. So Szymon, please take over.
Thank you very much, Ivana. So let me share the screen. Okay, I hope you see the presentation.
Yes, we can see it.
Okay, good afternoon, everybody. My name is Szymon Trocha, and I work for PSNC in Poland. And I'm the PMP service manager working in the GÉANT project. And this set of slides is in fact prepared together with my colleague from the project team, Ljubomir Hrboka from CARnet. And I will talk about the overview of what the service is, but also I'm going to give you some update of the current activities we are running in the service, look at some future ideas, and present a few directions we may go to. And one of the goals of this presentation is also to inspire you and maybe to get some feedback from you, how you see the service or what could be the future directions. Okay. Oh, yeah, works. Sorry. So first of all, let me underline that the PMP is the live service of the GÉANT project. So PMP stands for Performance Management Platform. And as you can see here in the GÉANT webpage, it's listed as one of the services under the connectivity and network management. And honestly, it's closely coupled with the other services related to what PMP is using or is based on. That means perfSONAR as a core software and the international collaboration. And it's also related to the consultancy service we are providing for our users in terms of helping them on the deployment of both the perfSONAR instances and supporting them in the currently running PMP platform. So this is all we are working on within our task in the project. So let me quickly remind what PMP is about. We started, well, in fact, a few years ago, and it was a natural evolution of the previous small nodes project, which was quite a success, where we deployed small devices. Small means devices of size like Intel NUC or gigabit bricks, which is 10 centimeters depth and 10 centimeters wide. And these low-cost hardware nodes were pre-installed with the perfSONAR software and distributed to the NRNs. What's important is that it's not just a small size, but it's also low cost. So we roughly talk about 200 euros per each of the device. And the, let's say, new ways of distribution was not only to give the hardware to the participants, but also to provide the fully configured node. That means the software was already pre-installed, the software was already pre-configured, and after connecting it to the network in the NRN or institution hosting the node, we were easily able to do the last pieces of configuration and easily connect to all the central components. Of course, we as a project are running some central components that manage the platform, which store the data, which collect the data from the nodes, and then made it available for the participants and all the users who wants to get to the data. We operate the service as a GÉANT project, so there is an operational team behind that, and we maintain the instances in terms of the configuration and the central components. It's also worth to say that this service is also nicely coupled with the GÉANT measurement points. The GÉANT measurement points are those GÉANT servers which are located in GÉANT POPs over Europe and are also running perfSONAR instances. And we use them, in fact, to create a kind of partial mesh and to run the tests, the regular testing between the PMP platform and those servers. So what we do, in fact, is PMP is using all this perfSONAR software. So it's what's there, in fact, is already immediately available to us, and we configure what is there. So we use all those basic types of tests available, like the throughput, latency, packet loss, the round trip type. And I think it's even a quite unique infrastructure in the world, possibly, to run the HTTP and DNS tests. So to measure the HTTP request time and the DNS query time, because these were the latest additions to the perfSONAR software made last year. And we also implemented that in our instances of PMP, and we run it regularly between the PMP instances. And a few selected websites, like those which may be of interest or importance for the community, like the GÉANT website, the google.com website, or the RipeNet website. So we measure and test those parameters. I think it's important to say that the service is not just all those small nodes spread over Europe, but also all these central components. And I want to say that and describe that because, and we were able to see that in the previous presentations from the users last day, that pieces of those are already implemented in those user environments, because we think that all of this create a kind of successful deployments for any perfSONAR measurements you want to have within your domain, both to operate the services properly, and to operate them efficiently and have the good support for the users of the service. So we as a project run this central server, which hosts all the measurement results. And it's not only collecting the data, it's storing that for longer periods of time and make it available for the visualization, but it also hosts all the Ansible configuration. We use Ansible to do some automation and management of the services, because you can imagine that at that size of the deployment, you cannot live without some kind of automation. And well, honestly, automation is the new word, and you can hear everywhere that people try to automate things. We do that too, and we really encourage people to do that. And perfSONAR already enables those for the users. We are providing the playbooks, and we are providing ways to automate the deployments and the operation of perfSONAR instances. So we do that through the central server, and that allows us to easily change the configuration of the mesh, to change the configuration of the node when we are upgrading them or adding new users or adding new tests. That simply makes all the life of the people who operate the mesh much more easier and efficient. We have the data, so we also have a visualization, all the dashboards provided via the MatDash user interface, so all the nice meshes where you can see and dig into the data. This is in fact publicly available, so anybody can access that through the user interface. You cannot have a proper service without an infrastructure monitoring, so we deployed the Grafana instance and Prometheus, which is providing the data. And we collect that on a central server to have the visibility of how the nodes behave, what's the CPU usage, the disk usage. We even monitor things like the number of tasks which are scheduled in the node, so that if something wrong happens, we are able to track that, and we can even be alerted when things go wrong. And finally, behind that, we have this operation team, which maintains all the central parts, which can react to monitoring, reconfigures all the nodes and central components, and also supports the users, and finally disseminates this information, like what we try to do now, in fact. So to say it once again, all these pieces are nicely joined together in the service operation. And if you are looking at some perfSONAR deployment, this is really the thing you should look about, and you can talk to us, and we are there to support, to, let's say, follow the same or similar path. Yeah, I mentioned the central dashboard. You can find the URL to the central dashboard here, so that you can see all the data we are collecting, all the results and nodes. And yeah, I'm just presenting here an overview here of the different types of tests. When the service was created, we had a couple of ideas in our heads. So first of all is that all the small nodes are available there for the users of the project and for the NRLs hosting them. So it's not only us who are collecting the data in the central instance of the archive, but this is also the users, the local administrators of the node, who can add their local measurements, the local tests to any of the available perfSONAR nodes in the world. So you remember those 2000 instances of perfSONAR, and it's there, it's locally configured and doesn't impact the rest of the centrally configured tests. So they can play with it, with the toolkit user interface and with the platform through the CLI. This can also be an example measurement, experimentation, and training platform. So as some of other users follow that path, you can create similar deployment through your local environment and use small devices in order to create some training platform or ad hoc deployments. It's also an easy way to set up because you can receive this box, which is already pre-configured. So it's a little bit different from what you usually do, so that you have the hardware, then install the toolkit and configure. It's there, it's given, and it's already working. And we can even provide our users with all the images which are available, and they can use that if they have their own hardware. And of course, that's providing all the tests available in perfSONAR, which are run in a regular manner, and the researchers, the user, can look at that and can make sure they get similar level of performance, and when necessary, they can add their own measurements to have their own visibility. A few lessons learned from the service. I already underlined that using small nodes is easy because you can easily move the device from one point to another. You can also easily ship that. That's what we are doing. It's not a proper server where it's quite difficult to ship. You can use a small package and send it to almost every place in the world. We are quite busy with, the devices are quite busy, but still perform well. On the right hand of this picture, you can see the schedule on one of our devices. Of course, if you remember, I think Ivan mentioned yesterday, all these types of tests like exclusive or those running in the background, they have different ways of running. And the P scheduler is using them to run different types of tests. But you can see that it's pretty well filled with all the types of tests. And well, we are using all these tests to provide you live measurements. Yeah, we do the automation. That's an important lessons learned. Automate as much as possible to make your operational life much more easier. You need to monitor the service, and you need to monitor the environment. You need to look at the disks you use, for instance, and the usage of the disk, because they sometimes tend to feel it's not about the data which is collected by the personnel. It's not always about that, but you may, for instance, fall into too much logging on the host, and then you are in trouble because your disk is filling quickly. So you can also consider remote storage only in case your small nodes or your devices have just a little bit disk space, so you can send the data only to the remote storage. So these are things at least to consider, or things which we learned over the couple of years of running the service. Service is covering pretty whole of the NRNs within Europe and beyond. So we are almost at the end of covering the whole Europe. So it's pretty quite extensive, and we can choose, in fact, any of the site in the NRNs to run the tests to. But that's not the end. And looking into future, we are trying to, let's say, downsizing the service and the platform rather. So we started with this gigabyte bricks hardware platform, and now we're looking into even smaller size like Raspberry Pi. And let me give you a few insights into what we did about that. We already have a few devices of the latest Raspberry Pi number 4, which are equipped with 4 gigabytes of RAM, the micro SD card with 32 gigabytes of disk size. And what's important, it's it has on the platform the Ethernet copper 1 gigabit Ethernet interface. So you don't have to use any conversions, but you can just plug your RJ45 connection, and you are there connected to the network. So it's even easier to place because it's smaller. You can use that for ad hoc networks in small communities during conferences or events to make the performance measurement. One note there, because it has the micro SD card, which is limited in size and it's a little bit slow. The remote storage is of course preferred in case you want to run regular measurements and to store the data in some other place. So we started testing, and yeah, some of you, I'm sure, remember this project many years ago, SETI at home, where you use your home computer to run some SETI calculations. So I was running perfSONAR at home due to these COVID restrictions, and I built a kind of test environment on my dining table, yeah, occupying most of that size, to build some test environment to make some initial configuration. But that was just initial. I built a proper test setup at PSNC to test the pies and to test how that works in the environment, and together with the other size of devices. So you can see I had 2 pies connected via switch in Poznan, and then a couple of other size of gigabit bricks, which I used to make some testing and to get, in fact, the reference values for Raspberry Pi. So the Raspberry Pi comes with the pre-installed Pi OS, which is based on Debian 10. By the way, Debian 10 is not yet officially supported, but we were still successful because it supports the test point installation. If you go to the perfSONAR bundle, there is a test point which contains all the necessary tools to make a perfSONAR node working and to schedule all the tests. So I was successful in testing that and installing. I was even partially successful, in fact, in the toolkit installation, which went smoothly, but not yet ready to run all the tests. So let me go to the first results we get from the Pi. So here are the results I got from one Pi to another via switch. You can see the throughput test. It's went pretty well, 940 megabits per second between the 2 devices. So it's, I would say, the reference value similar to all the other devices which are used. Of course, you have to imagine that these are the, let's say, reference values. These are the tests which run exclusively between those 2 devices and not in a larger mesh. But they show that you can easily get these values between the 2 Pis. I was also trying to stress a bit with latency tests with OW ping. You can see a table of comparison between the different number of packets sent over the tests and so that's the number of packets, like 10,000 of packets, and the interval between packets. So it went well up to, let's say, 10,000 of packets. And after that, you started to see some packet loss at the level of less than 0.5% up to 5 or 7%. But honestly, when you look at this table, the default value of number of packets per second when you run the latency background tests with perfSONAR is 10 packets per second. So it's just the first line. And here is a result I did between the Raspberry Pi and the remote gigabyte bricks. You can clearly see when the bandwidth tests were running because it had some impact on the latency. But anyway, I was able to get about 800 megabits per second of the outgoing traffic and a little bit less of the incoming. Comparing to the traffic between the 2 gigabyte bricks PMP nodes, it's a little bit less, but honestly, I didn't have those 2 in the same exactly network place, so there may be an impact of the LAN between Raspberry Pi and the other node in Poznan. So I did that between Poznan and the ESnet to have the, let's say, remote reference. This is something we still want to continue to have more, let's say, reference on the remote deployment. So we will conclude with those tests. And as we have a couple of those devices, we want to distribute them over the NRNs and then run more testing between the remote sites to collect more feedback and to have more basic data. that's about the testing of the new platform. And now we want to look into the future of the service, and that's something we want to have some feedback from you. We are thinking about new ideas. So what should we work on, not only in the when we implement new features within the service, but that also strongly depends on what we are developing in perfSONAR as a software core. So looking at some testing where we can show how IPv version 6 is covered in the networks. We started to do some work on the data analysis, and there will be a few slides about that. We still continue with the footprint extension, but what about the AI testing? Is it interesting? We can do something about that or not. That's something in the horizon. Also, cloud testing is possible of interest for us, where we have those cloud providers and want to measure the performance between the NRNs and the cloud providers. So that all impacts the PMP service and maybe new directions. So we want to hear from you, seeking the input from our users or from the NRNs and the institutions which are possibly using the instances, because there may be features which we didn't think of, but we want to build them into the service. Thanks to that, we identify the product improvement areas. We feed that to the global developers team, and we can include that into our product roadmaps. So that's why we're discussing that, and you as users motivate us, and we deliver the better service for you. So please use the email address here if you have more suggestions or more comments. We will be waiting for you. And final slides are coming from Ljubo. That's more about a new work which is related to data analysis, big data, how you call that, artificial intelligence, because as you may imagine, we already store a lot of data from the last 6-7 months. It's about 600 gigabytes of the data coming from different types of tests stored in databases, both the metadata and the time series data. And we wanted to make use of that because there is this Esmond REST API where you can get the data from the central archive and maybe learn something from the data. So why not? The work Ljubo is doing is to develop some kind of model that will help us to detect the anomalies in network monitoring data, detect possible issues in the network, or possibly, and maybe predict some future behavior. That can support not only the NRNs, but the institutions, maybe those which are looking for some longer time performance data or looking at some issues which may arise in the future. And what we do within this area is to get into the historical data via the API. We are going to import that into the ELK stack to make all these preparations for analysis, to examine that, maybe to clean it a little bit before we analyze, and then develop the AI model for anomaly detection. That's an ongoing work, and I'm sure Ljubo at some point will present more details and more details on that. And that's in fact it. So if you have any success story which can inspire us, please share with us. Please share your comments and ideas how we can improve the service and what kind of features you are looking for which are not existing. But it's also a story about how you used the service in order to help your day-to-day work. And yeah, that's it. I feel I made it a little bit longer than my timeline, but yeah, hopefully that's still okay.
Yes, no worries. We have some contingency in the Q&A session. So there were some questions and comments in the chat. One was from Jim asking, are some of small nodes behind host site firewalls? So Antoine did answer that we actually suggest that nodes are as close as possible to the core of the network, but that there are some of the nodes that are behind the firewall. So Szymon, maybe if you have any additional comments on the experience with setting up and managing these nodes.
Yeah, I mean, that I would say this question applies to all, in fact, perfSONAR instances which could be behind a firewall. That's usually something we do not recommend, but if you want or you have no other choice to deploy it behind the firewall, there are these rules we can provide in order to pass the traffic. But from the user's point of view, we always say that, okay, even if you have a perfSONAR instance behind the firewall, it's presenting the view of the users from behind the firewall. So, but there's also a possibility that you can have another instance which is in front of the firewall, and you have a comparison of the performance behind the firewall and in front of the firewall. But we do have sites which implement perfSONAR instances behind the firewall, and that's completely working fine.
Well, thank you, Szymon. Jim, does that answer your question? Okay, thanks. And also there was a question from Darren. Did you use 64-bit version of Raspberry OS?
That's something I need to check. Don't remember that now. I will answer that into the chat.
Okay, and also Darren was sharing some experience with working with Raspberry Pis. So Darren, do you maybe want to comment it online?
Yeah, just a quick one. Using the Raspberry Pi 4, there's an updated firmware out now which allows you to hook up an SSD via a UASP-enabled USB 3 to SATA cable, and you can actually boot off the SSD and use it as main storage, which avoids using the SD card entirely.
Yeah, that's true, Darren. I agree. That's possibly. I would say you are losing then a little bit of flexibility of this small device if you need to attach something else to that. So it's yeah, but it's up to you and it's up to the local environment, I would say. Yeah.
Yeah, it just depends if you need more storage locally.
Yeah, yeah, sure, of course.
And one final point on that, did you also change the Linux kernel scheduler?
No, nothing yet.
Right, okay, that may help as well.
Yeah.
There was also a comment from Mark about the back-to-back testing, and also I fully agree with the more perfSONAR nodes, the merrier. So any additional comments, Mark?
No, I mean, I guess the thing about and Szymon kind of covered this, I think, but you know, the whole point of perfSONAR is to debug problems from the perspective of whoever's trying to get the data from point A to point B. And in a lot of cases, you know, if you have something, and we saw cases like this, Doug Southworth talked about this yesterday, where, you know, there may have been perfSONAR nodes that were as close to the edge where you connect to the backbone as possible. But if your problem is, say, on campus, then you're not going to see any of that, which is kind of why it's important to have lots of nodes. And I mean, the great thing is, and this actually sort of answers the question that Ano asked a second ago. In a lot of cases, the best thing to measure is latency and loss and throughput. And you don't actually have to have a big node with a fat pipe on it, because TCP is that sensitive. So even if you're measuring gigabit, the minute you start to see a little bit of loss, and again depending on what the latency between the points looks like, you'll start to see loss even at low speeds. It's pretty pronounced.
And I think there's plenty of these test types which you can use. It's not just the throughput, which is obviously, I would say, the most visible, how we call that. Yeah, okay, you can get 940 out of 1 gig, but there's plenty of others which makes the node very useful.
I think that point is really good, Mark. But network engineers are also quite nervous, or operators are nervous of using the full bandwidth of a link to demonstrate that you can push at the full speed. So looking at loss and latency to deduce what the issues are is important. But equally, it's important to be able to know how to drive perfSONAR at 100 gig to do 100 gig test if that's what you want to do. And I think that's an interesting topic in itself. But I know we're behind time now, and Ivana probably wants to move us on.
Yes, I actually wanted to ask Ono if the replies so far were okay related to this question.
Yes, that was very informative. Thanks all.
Okay, thank you. So thank you, Szymon. I would now like to invite Magnus and Christopher to present their experience of using perfSONAR in a campus network management environment. So Magnus, are you sharing your presentation first?
Yeah, sure. Let's see, 2 seconds, should be there, right?
Yes, this is okay, thanks.
Good. Yeah, so my name is Magnus Bergroth. I work for SUNET, the Swedish university enron. And I also worked for NordNet as well. But in this particular case, SUNET has started a service that's called the Campus Network as a Service. And that began from requests from the universities. And some of the universities saw that they had started to have problem with securing their knowledge to network, running networks, so to speak. There are a lot of small universities that only have one senior network engineer, and in Sweden, at least, they tend to stay quite long at the university, and now they're starting to get to the age that they actually started to retire, and it's hard to get new people. So they're looking at this to be able to share the knowledge between the universities with this campus network as a service, and also a way to do joint procurement of equipment. And also that the staff that works at those universities is able to work at other universities with their network as well. So basically share that knowledge. So currently we have 2 universities that are involved in this. We had a small university in the middle of Sweden that has been running the campus network as a service for almost a year now. So far, they haven't had any staff on site because there was a new campus, and they basically they put the network in full production in April, and in March they basically said that everybody should work from home. So they haven't really tested the network yet, but it's still there. And then we have the largest university in Sweden, the Stockholm University, that also went on this. So it turned out that it was actually the larger university that was interested in this service than the smaller ones. That was completely opposite of what we thought from the beginning. Well, we have a couple of more in the pipeline going on this as well. So what we look at on this, to be able to do a campus network as a service, we need to streamline it in some way. And we need to build it on something that we can rely on and use for the future. So we decided we need to do something that everybody else does. And the big thing that most do nowadays is build like data centers with this leaf spine situation. And one other important thing in this was basically to not to have any vendor lock-ins. So basically just open standards, and then basically do automation in every level of the whole thing. So automation in network deployment in our case is basically that you should be able to plug in a switch. It should be auto-installed with zero-touch provisioning and up and running like in a couple of minutes. Automating network operation is basically the day-to-day work. You shouldn't need to log in to switch to set in the VLANs or do any change on the device at all. and also the documentation, how the switch is connected and to what all the ports are connected to should also be automated documented. And then we come down to this point where we are looking to using perfSONAR. Is basically we need to do automation in networking monitoring as well, and then that's actually monitoring on the very edge of the network. So the whole design for this was basically that we had a design where all access switches should have dual uplinks. Any component in the network should be able to be down for a couple of days without anybody need to rush in to replace anything. So all the underlying levels should be fully redundant. You should be able to replace any component with any vendor components, more or less. And it should also be able to upgrade the software on the devices during the days, and not to able to have a service window in the middle of the night just because we need to run some new software on the box. The only thing that's single point of failure is the access switch itself. So because we only connect one laptop with one cable. So the university that we started with actually did a fully, their wireless network is fully covered. So we can actually upgrade the switches in that case, because even though half of the access points are down, they still have decent coverage of the whole campus. But removing that thing about vendor lock-in, it basically exclude any multi-chassis lags situation, spanning tree and virtual chassis things. And that ended up running VXLAN, using BDP in the core, EVPN, and EVPN ISI multi-homing. That's basically. And in bigger networks, we have a core network that's basically just forwarding IP packets, and a distribution layer where we terminate all the IP routing and connect all the access switches to. And then we build this network automation system where we have inputs where we give all the data for the network to build the configuration of the switches. And you basically just provide the parameters for networks, like what VLANs you want to have, what IP addresses should be on which VLAN, and those kinds of things. And from that, it builds with the help of templates. It builds the configurations on all the devices. And if you change vendor, you just change the templates, and then you generate the configuration on the boxes. One specific thing that we decided to do is when we do a configuration change on a device like a switch, we do a full replacement of the configuration. So if somebody have done any change on the box, it will of course be alarmed that there are local changes. But when you sync that box with a new configuration, it would basically going to replace all the configuration on the box. So it's going to be fully restored to the template and the database situation. And then we have an operation model where we basically have the help desk is the university. The NOC is actually our own NOC. And then we have the engineering, that's a combination of SUNET and university. And the developers are our own. And the hands of feet are universities and the contracted universities. So we had some problems during the first deployments, and we decided that as long as possible, we wouldn't like to have any fixed VLANs on any ports on the access switches. So all the ports are assigned a VLAN using .1x or MAC authentication bypass, whatever the abbreviation is for the moment. Is basically that when a device connects to the switch, if it can do .1x, it's going to authenticate that way. If it can't, it can send its MAC address as its username and password and send it down the radio server. Of course, you can spoof your MAC address in that case and basically get access. So what we also do is that we send the MAC address and the port and the switch name, and then we have a central database to say that this port, this switch, this MAC address should be on this VLAN. What happened in the startup was that when the switch booted up, it didn't have access to the radio server, and it put the switch into the fail VLAN, and some printers got the wrong IP address, and they got stuck there. We have a radio server that was running out of disk space, and we even have problems with certificates that couldn't go through due to jumper frames. And then there was all this hassle with the university's firewall that sometimes denied things and sometimes allowed where it shouldn't go, and IP scopes running out of space, out of IP addresses for the clients. So we found out quite soon that we needed to somehow simulate a client to be able to test that this actually works. Because relying on the users to complain that it doesn't work, it doesn't really run in a long while. It works for the first couple of times, but then people start getting annoying. So what we wanted to do was to verify the access to the network. So we want to connect the client. We want to do a .1x authentication, use a password, username and password. We also do both from local account, but we also do eduroam on fixed wires. So you can connect your computer on the cable using your eduroam credentials as well. We want to do .1x with certificates, and we also want to do the MAC authentication login, and we want to test the fail VLAN. That basically means that we need to have our test probe do this test over and over again with different credentials and different authentications. And we want to see that the users get connected to the right VLAN. And that's basically only way for us to do that is to see that the client gets the right IP address from the right pool. Then we know that it's connected to the right VLAN. Then when we are connected to the network, we want to know that the DNS is working. We want to know that we have access to some public services, but we also want to know that if for example, is connected to the passive systems VLAN that's handling all the doors and stuff like that, I shouldn't have access to any public services as well. So a failed in a public services connection is good in this case. So a connection is a fail in that state, and also connect to local services. And if I'm, for example, connected to the student network, I shouldn't have access to the economy servers and stuff like that. We also want so with persona, this is PF, this is PS tests. We basically have a persona node, and as we want to run these tests with different IP addresses and different VLAN assignment, we very soon got to the conclusion that we needed to have a management port on these devices as well. So one port that we can access the node to request the test being going on, and one port that we actually do the monitoring on. And with this situation, at the moment we don't know at least how to do a probe-to-probe measurement, because you first need to do the authentication, then you need to do the tests. If I have two probes that first need to do authentication to get to the right VLAN and then do the point-to-point measurement, that's two tests in a row that needs to be synchronized and in place to get that working. Maybe there is a solution, but I don't know a bit. So we do all the tests to a central node that has a fixed IP address all the time. So looking at the probe and the hardware. So we had some requirements for the probes. We didn't want any power adapters because we know that they breaks. We want to do a remote power cycle of the devices because they hang sometimes. And that basically concluded that we want to use power over Ethernet to drive the device. We need to have dual NICs. It needs to be rack mountable because these loose boxes laying around in a cabinet doesn't work really. no fans. It needs to run persona and needs to be cheap because we want to have many probes. Basically, we want to have one probe in every closet. So as Szymon also pointed out about the Raspberry, so we looked at the Raspberry. It does the job. It only has one NIC. It doesn't have power over Ethernet. Well, it has a power over Ethernet hat, but that has a fan on it as well. So then we have a fan on the box. There is this NanoPi RS2S that has 2 NICs on it, but it doesn't have power over Ethernet, and it's not that available at all. So what we found out that there are quite cheap components. So we looked at this USB to Ethernet adapter. It's only 11 euros. And then there are from multiple vendors these PoE splitters. So it's basically you connect your cable in one end to the switch, and then you get another port they connect to your device, and you get like a micro USB cable that you can connect to your device. And if you use all those components, you get a device that costs less than 100 euros. But somebody said before, it's a lot of like dongles and stuff hanging around. But you can actually remove the cases from these dongles. So and there is a PCB inside. So and all of a sudden you have the bare components. And you connect them like this. You snip up the cable for the USB micro USB cable, and you solder them directly to the Raspberry Pi's plus 5 volts and ground pin. And then you get somebody to design a 3D printed case for you. In this case, my son had to do it, and you basically stack all the components into the box. And you can see the front plate here. You have 2 Ethernet ports. We have the USB cable that's connected to the USB port. And what we do is we use the main port on the box as the monitoring port, and the USB Ethernet port with the power Ethernet port as the management port. That means that we can use that ports on the box that we have that performance on to do tests on, and then we just shove the data for the measurement on the measurement port on the management port. And then we have all the ports for the Raspberry on the side if you want to. So if you need to do some debugging, you have the USB to connect your keyboard and mouse and your HDMI connected to it. And then now we have a rack mountable box that we can connect to the switch. 2 cables, one for the management VLAN and one for the test thing. And we can reset it using power Ethernet when we do something wrong. And we can do the monitoring. At the moment, we have built in a total of 14 boxes that we have out and running. 2 running at university, and a couple of more at the first university, and then we're going to install a bunch of more at the Stockholm University. And as someone says, well, you can run like a bit over 900 megabits throughput on them, but we're not that interested in the throughput measurement. We are going to do mostly the thing on connectivity issues and that you get assigned the right VLAN and that the authentication works. So I leave over to Christopher to talk about the authentication part. That's not a part of perfSONAR at the moment.
Okay.
I'll stop sharing.
Yeah. I'll try to share my screen. Can you see it? Yeah. Okay.
Yes.
Yes.
So I will talk a little bit about the development of this new plugin for .1x authentication and how we were thinking and what we were doing. So as Magnus said, we wanted a probe which is easy to deploy and manage. So we decided to go with a somewhat standard Debian distribution called Raspbian. And the goal is to have a simple installation with as little manual intervention as possible. I mean, there's most of the time you will just clone the SD card from one Raspberry Pi to another. And quite rarely you will have to do the whole installation from scratch, but for sure it will happen. And we will probably run into situations where we want to upgrade the whole system and deploy everything from scratch. So we decided to build our own Debian packages and stuff. And in the future, we will probably run a Debian package repository as well, so we can do easy upgrade and things of the packages. For everything else at SUNET, we're using a Puppet to automate things. So the plan is to use Puppet for this as well in the future. So we won't have any manual integration for upgrading this either. It should be fully automated. So in the simplest form, we want something that authenticates over .1x, for example. And it doesn't really matter if that is successful or not, but after that step, we want to try to acquire an IP address. So we want to do some setup here, and it will probably be a bit different from what we are doing compared to what will be done if we manage to merge this into the real perfSONAR in sometime in the distant future. Because when the probe boots up, it will create a network namespace and some other things needed to run this. But if we merge this into the real perfSONAR repositories, this should probably be handled by the test itself to make things as automatic as possible. But once everything is set up, we will try to do the authentication. The problem we had here is that we want to do a couple of different sorts of authentication. We want to do .1x with TLS certificates, for example, or PAP or something else. So we will have quite a few options here. So we will try to authenticate a few times. We found out quite quickly that it sometimes we have to try up to like between 3 and 5 times before the authentication is successful. So basically, okay, a while, then try over and over again for a maximum of 5 times or something like that before we go to the next step to acquire an IP address. We don't really care if this step is successful or not. I mean, it doesn't matter if the authentication was successful or not. We'll try to get an IP address anyway. Because if we can get an IP address without being authenticated, we clearly have a problem. So we want to try to cover that case as well. And lastly, we will have an optional step of teardown where we basically restore the system to its default. Or in some cases, we won't run this step because we want to do some other tests anyway, with some other tests that's required that were authenticated. So if we look into the first step, which is doing we had to figure out a way to do .1x authentication in Linux. And basically on the same way I'm aware of is to use base applicant. So we had to interact with base applicant in some way. And there's a few different ways to do that. There is dbus control interface. I found some Python libraries for that, but I couldn't find anyone that really did what I want or worked real well. So there's also an application called VPA CLI, which is basically a CLI application for base applicant, where you, as you see in the picture to the right, you can enter commands. For example, select which interface to use, add a new network, and set a bunch of parameters together with the identity and password. So we ended up going that way. And in the perfSONAR code, what we basically do is to spawn a new process that sends different commands to WePay CLI. I would have preferred to interact directly to WePay supplicant over the control interface, but I guess this way works as well. In the next step, where we try to get an IP address, we basically just launch a DH client. We'll try to get an IP address, and it will write the standard out if it was successful or not. And if it was successful, we can fetch which IP address it was. The problem we had from the beginning was that when we acquired an IP address, we lost connection to the probe, because the default route will, the default gateway will be overwritten when we get a new IP address. So we ended up using Linux network namespaces together with perfSONAR. perfSONAR already had support for that. That made life quite easy. So when the probe boots up, a new network namespace will be created. Our test interface will be associated with it, and we can use it for everything. And that makes the management interface always available, and we don't risk losing connectivity to the probe at any time. Once we figured out how to do everything, we had to glue things together into a test and a tool. I went down the hard way and basically copied something existing. I think it was the trace test and tool. Someone pointed out at a later stage that there is actually a plugin development guide. And there's also a few scripts that will create stubs and everything for new plugins for you. But, well, that would have been a lot easier way to do it. But when we started to implement the test, we had to figure out which command line arguments to use. As you can see on the last line here, we want to pass an interface to the test, what EAP type we will be using, for example, TTLS or PAP, username and password, and maybe a bunch of other parameters. We want to validate the input. So, for example, it should not be possible to pass an interface that don't exist. And once we have a result, we want to print it, have a nice output. And probably a lot more in the future. The tool will basically take the information provided from the test. And once the tool has finished its execution, it will send back a bunch of JSON. And yeah, so basically the tool is responsible for interact with WePay supplicant, the DH client, and all the other things needed. This was actually the hardest part of the development. So I started writing Python code for interacting with WePay supplicant. So I ended up basically sending a bunch of JSON into one of the perfSONAR pieces, which is responsible for running the tool. So basically that was just an iterative process of doing development, try to pass the JSON structure into it over and over again until it worked. One thing that made it a little bit harder was since we had to run this in a network namespace, it was a bit difficult to do the whole development using perfSONAR. If we launch one of these tests manually, we will have something like this. We can see here that we have a context where we will tell which network namespace to run it in. We will tell which tool to use, interface, EAP type, and so on. And in this first version, we will have, well, it's not a lot of information here, but we can at least see where we're associated, which MAC address we have, IP address, and so on. If we fail to authenticate, for example, the first two fields will be missing. If we didn't get an IP address, well, the IP address will be missing, of course. We have this test running continuously. So basically, we will launch the test, wait a few minutes, and run it again. We are not using Mad Dash or anything like that because we don't really have any interesting data to show there. So what we ended up doing was to use syslog because all the test results will be written to syslog in the form of a JSON structure. So we will forward that piece of information to a Greylog server. And in Greylog, we can actually create rules where we can see if the test fails or not. And if we have a certain amount of test fails, we will send out a notification to a Slack channel. So if something failed here, we can see which host it is. Now all probes should not be named like Raspberry Pi because then we have no chance to see where the fault was, but have a better host name. And ideally in the future, we should include some more information about exactly what failed. And this will also make that Greylog will be responsible for storing all test results and things. To package this, we used Debian packages. Each package has its dependencies specified, so when you install them, you're quite aware of what is needed to make it work. Right now, in our setup, the packages are responsible for all configuration. So if you have a newly installed Raspbian system and install the packages, everything will be taken care of. We will make sure that network namespaces are created when the probe boots. We will make sure that the interfaces are assigned to the namespace and so on. So it's extremely simple to install this. And most importantly, we have to make sure that the base applicant is actually running inside a Linux network namespace, because that's where the interface is available. And as I said before, it must be possible to do an easy upgrade of this. And if we should merge this upstream into a pscheduler, there's a lot of things we have to rework and make a bit more generic. In the future, well, extend with support for Wi-Fi. It should be possible to specify which channel to run on, frequencies, SSID and things. Right now, we're basically only supporting wired connections. More generic packages, maybe merge it upstream, and I'm sure there's a lot of other things we can do as well. Okay, it was quite a quick presentation, but any questions?
Thank you very much.
Hello.
Yep.
Yes.
Go ahead. Matej Vadnial from Arnes. Regarding this plugin check, we're actually at Arnes, we actually started looking into implementing pretty much the same kind of check, something that will check if Edge ROM authentication is working. So we'd be quite interested in using this, and actually if it's integrated into perfSONAR, so it's easy to deploy, that would be a big benefit to us. So just a short question regarding the DHCP client. You said that you use two Linux namespaces, so the DHCP client doesn't override your default route. Have you checked into actually specifying the configuration of the DHCP clients, so it doesn't commit the configuration to the network stack, so it just does a dry run or something like that?
Yeah.
Because
yeah, absolutely. So basically, we have two options there. We can use DH client, which will output all the information you need to standard out, or you can use DHCPD, which is more flexible, but it's way harder to get information from it. And now I don't remember correctly, but I think we ended up using the Edge client because it's way easier to use. It's much easier to get information from it, but we couldn't really find a way to tell it to not replace the default gateway and stuff. Now it was quite a while since I did it, so I don't remember clearly, but I think that was the reason. And we kind of want to protect the test interface as well, so running in a separate namespace sounded like a good idea.
And it's also like we wanted to run in the future, run other tests when we actually have got the IP address, because if you connect to a VLAN, for example, as I said before, the staff VLAN, we want to see that we have connectivity to the outside world for that as well.
So you're actually running other perfSONAR tests over the interface that you connect to the network? I mean, if the test for the authentication DHCP succeeds, do you run like a bandwidth test over that interface?
Yeah.
Also, or
exactly. So for any test to succeed, basically, we must be authenticated. So the plan is to authenticate ourselves first, make sure we get an IP address, and then we'll run a bunch of other tests. So let's say, for example, that you end up on a student VLAN, then you shouldn't have access to, for example, some other system. Then we can make a separate perfSONAR test running after this test to validate that. But I don't think we will make it bandwidth tests, but there are quite a few other things we will do.
Okay, cool, thanks.
Thank you. Maybe we should then try to set up a meeting between RNES and SUNET and see which of these things would be of interest, maybe to be included in perfSONAR distributions in the future. So we can actually initiate such a meeting. We do have all the contacts from the list. So thank you, Magnus and Christopher, very much. In the chat, some discussion continued related to testing of for example, within a data center. I think that the conclusion might be that actually depends very much on what exactly is needed, what we want to check, what we want to learn, and how often we would like to have this information. So, for example, probably full bandwidth testing on all links would not be doable all the time. So periodic tests maybe on the link setup might be useful, but there are also so many other parameters that could be measured using perfSONAR. So maybe in a data center, some other things like latency, jitter, packet loss might also be of interest. Ed also made a comment because we know that University of Michigan is also looking at Wi-Fi monitoring. So Ed, do you maybe want to comment something now?
Yeah, we have developed an external program that basically scans Wi-Fi, it detects BSS-IDs, and then uses WPA supplicant to auth to each individual BSS-ID. Then it triggers perfSONAR to run latency and throughput tests. It would be really neat if we could, instead of doing that, we could have perfSONAR itself, you know, either scan for BSS-IDs or, you know, switch BSS-IDs. So your test tool pair would be very interesting to us. We also have experience with test and tool development. We actually are the ones that created the plugin development kit. So if you wanted to collaborate, if there was a collaboration going on with that, I have 3 interns from May to July this year, and I could spend some of their cycles on this as well.
Thank you, Ed. We are now approaching the end of this first session. According to our agenda, the break is until 2:35 Central European Summer Time. See you all in 15-ish minutes. Welcome back, everyone. This is our second session today. We will have 4 presentations. The first one from Mark. Then we will have the presentation from Ed Colone from University of Michigan about deployment practices for 10G mobile persona test points. Then the presentation about CentOS and OS support by Mark and Antoine. And finishing with the persona roadmap by Antoine. Mark, the floor is yours.
Okay, thanks, Ivana. Good morning, or I guess good afternoon for most of you. I'm Mark Feit. I think probably most of you know me by now, but I work for Internet 2. And I'm also a member of the PerSONAR development team. And today we're going to talk about bringing new measurements to PerSONAR. In some ways, this is actually sort of a good segue from what Christopher talked about a few minutes ago before the break. And being that we're a little time constrained, I think we'll just dive straight in. pScheduler's one of pScheduler's more interesting features is that it has a plugin system that allows you to expand what the system is capable of doing. And there are 4 types of plugins. The first are test plugins, which represent a measurement in the abstract. The second type is a tool which carries out, which is responsible for carrying out the measurements that are described in the tests. There are archivers, which are there to dispose of measurement results, to send them off to other systems for processing. And finally, there are things called contexts, which make changes to the environment that a tool lives in when it's actually carrying out the test. So when the folks from SUNET were talking about using network namespaces, one of the features that they were using was the context to make those changes. So today we're just going to talk about 2 of those plugins. We're going to talk about tests and tools because archivers and contexts are a little out of scope, and unfortunately I don't have an hour to discuss everything. So let's talk real quick just about the sorts of things that you can measure with PerSONAR. Pretty much everyone is familiar with what I like to call the usual suspects, which is throughput, latency, round trip time, and path. That's the things that that most people are used to measuring. There's also a set of what I like to call the less usual suspects, and that's things like DNS response time. S3 throughput is a new thing that we just added last year. SNMP values, network reachability. Now, the thing about all these is they actually do ship with the current release. 2 of them, the SNMP and network reachability plugins, are not installed by default for security reasons, but they are there. There are even some really unusual suspects like path MTU or voice over IP call quality or traffic dumps from interfaces. Now, none of these things exist yet, but they have been discussed, and they're certainly not outside the realm of possibility. Going a little further to the way out there are things that don't even have anything to do with networks. So things like stock prices or weather or the state of your garage door. And those actually are here as thought exercises. We don't have any plans to do them, but the architecture would certainly allow for us to do it if we were suitably provoked. So it's the opportunities there. pScheduler has kind of a formula for doing measurements, and that's that you take a test and a tool and you put them together, and that's how you make a measurement. There are some requirements for tests and tools. For tests, the measurement and its results have to be describable in a very concrete way. You can't do anything really hand-wavy with this. For tools, you have to have a program that can do the measurement. We're not in the habit of developing those because we're sort of in the integration business. But lots of people have written lots of tools that do measurements, things like ping and iPerf2 and iPerf3. The second rule for tools is that they have to be usable by another program, so we can't really invoke anything with a GUI, that sort of thing. And the final requirement is that the results have to be readable by a program within the tool plugin. Now, that doesn't mean that the tool has to produce machine readable output. It's awfully nice when it does, because it does let us, it does make the development process a lot easier. But we've certainly written our share of things that paw through human readable output and pick out the results. Ping and trace route, by the way, are two prime examples of that. So next, we're going to talk about a little bit about test design, which is kind of in a lot of ways, is the hardest part because it requires the most thought. We have some philosophical things that we like to encourage both ourselves and others when designing a test. And the first is that you should begin by focusing on what's being measured and not so much the tools doing the measuring. We're really looking for something abstract but still useful, I think would be a good way to put it. We do, however, recommend surveying the landscape of tools that are available to take these measurements and just kind of using the capabilities that those tools have to inform the way you design your test. You kind of don't want to do it in a vacuum. We also recommend against making a test a proxy for a specific tool. Because doing that tends to hamper flexibility in the future. If you get yourself locked into a specific design that centers around a specific tool, and all of a sudden you have a new tool that works just differently enough, then all of a sudden the thing that you've done that's not very abstract has to be redone, and that kind of complicates things. Now, I know we weren't going to discuss this, but I am going to bring up something I mentioned before, which is the garage door test. This is actually a pretty good straw man for the test design process. So let's say that for some reason you have a business reason to determine the state of garage doors that happen to be connected up to your network. And you want to know three things. How far along is it in its travel, i.e. is it open, is it closed, is it somewhere in between, is it moving, and which way is it moving? Let's further stipulate that we've surveyed the landscape of network connected garage door controllers, and we've found that they speak a couple of different protocols that we care about, and we'll just call those DoorML and Megadoor 5000 for lack of anything better. And also our survey revealed that some of these controllers, if the door is moving, some of the controllers don't give you an answer until it stops. And that I threw that in there really just to complicate things just a little bit, so that the test design becomes a little more robust. So really, when you're designing a test or new measurement, you start with a specification. So I've actually written a short specification for what the garage door test looks like. In this case, it has three parameters. It has one called door, which is the IP address of the host name, excuse me, of the door that the door controller you want to talk to. So here the sample value might be, let's say you have some warehouse called Chicago 6, and it's got a whole bunch of loading docks, and you want to look at the one at dock number 17. The second thing is the protocol that you use to speak to the garage door. So in this case, DoorML, Megadoor 5K, and also the timeout, how long you want to wait for an answer. So if you know that your doors take, maybe 5 seconds to travel, then maybe you set your timeout as 10 seconds or something like that. Now, a couple of points about some of these parameters is that in a lot of ways they sort of aid pscheduler in its operation. The first being that specifying the protocol enables automatic selection of tools that can speak one or more of them. And we'll talk a little bit about how that process works in a few minutes. Additionally, the timeout is useful so that the tools can come up with an estimate of how long it's going to take them to run the measurement that you're going to ask them for. So in this case, we might say, okay, it's going to be 10 seconds worth of timeout and maybe a second or two of kind of slop on your side just for setup and teardown. So this measurement, for example, might take, the tool might say, okay, I'm going to take 12 seconds to do this. And that's important because, because pscheduler works, it actually has kind of a calendar or an appointment book that it uses to book all these tests in. The important thing to note here is that this is a standard test specification for all tests of garage doors, no matter what tool is doing them. All the tests look alike. One of the things that we ran into during the design of pscheduler, we got a little worried that we were going to have to kind of cater to the lowest common denominator in terms of test parameters and things like that. Turns out we actually were able to do the opposite. Test parameters and specific values don't necessarily have to be supported by all the tools because the tool plugins declare to the system which tests they're willing to run, and they have something in them that gives a yes or no answer about whether or not a given test spec is something that they can handle. And pscheduler has this process where when you give it a test, it will shop that test around to the tools that claim they can do it to find suitable candidates. So, for example, in the garage door example, if you're trying to query a garage door where the controller speaks door ML, the ones that don't speak door ML will just give a thumbs down and say, no, I'm sorry, I can't do that. The result of that process is that you'll get either a list of all tools that can do that test as part of an automatic selection process, which is kind of the usual thing. Or if you specify a list of tools that you want as candidates to run the process, pscheduler will just shop around to them and stop at the first one that says yes. So for example, if you're doing throughput, you say, I want this with iperf3, iperf2, or nothing, the first of those two that's able to do the test is the one that'll get the nod. And finally, at the end, if you're doing automatic selection, then the tools that say yes are sorted by a thing called a preference order, and the one that comes up highest in preference is selected. The preference order is something that we put in there. It's just an integer, and we use it so that we can give some tools preference over others in the automatic selection process, and it lets us introduce new tools and deprecate old ones without the users actually having to do anything special or even know that it's happened. Now, obviously, you've got a measurement. You have to have a result that comes along with it. I've written one of those as well. In this case, the result of your garage door test just has two things in it. It has a position, which is a fraction of how far the door is from open to closed as a floating point number. And I stole the results of most languages comparison operators to say which way the door is moving. So if it's negative, it's moving toward closed. And if it's not moving, it's 0. And if it's moving toward open, then it's 1. Again, the important point here is that this is the standard result for all garage door tests, no matter what tools do it. If you've been using pscheduler for any amount of time and you've done, say, throughput tests with different tools, you may have noticed that all the output looks a lot like what iperf3 spits out. There's a reason for that. There's actually standard result as JSON that gets formatted to look like iperf3 no matter which tool produced it. We kind of did the iperf3 format because people were used to it, and it sort of aided the transition from BWCTL. So having sort of covered the design aspects, I'm going to shift gears here and talk a little bit about the mechanics of how plugins work, because it's kind of an important concept as well. Generally speaking, actually, this is not even general, this is true for everything. Every plugin in pscheduler is represented as a directory containing a standard, a well-known set of things that I call methods, and that term is stolen directly from object-oriented programming. So each method basically has a purpose for that plugin. It might be to do something like validate input, like a test specification. Might be to do something like determine if a measurement is possible, or to carry out the measurement and produce a result. The standard set of JSON that it expects on the standard input, and it writes an expected set of JSON on standard output. And I would point out that there are a few sections of some of these bits of JSON that are freeform and get validated by other plugins. It's another discussion. And these things exit 0 most of the time, or 1 in the event of a really catastrophic failure. Most times, even if there's an error, the plugin will exit 0 and will still spit out some JSON that indicates that. We have sort of a really severe definition of what failure means. Now you'll notice that I said that each of these things is an executable program. That is absolutely true. The plugin mechanism in pscheduler runs on a process boundary, which means we run external programs to do all these things. And that really, we do that. It was a conscious design decision to do that. And we do it because it buys us 3 things. The first is that...
Hi, Mark.
Yes.
Sorry to chip in. I'm seeing slide 13, but I've got a feeling you're a bit ahead of that.
You may be right. Let me stop share and start all over again.
Cheers.
I apologize
No
for
problem.
that. Thanks for, yeah, no, please. Thank you for pointing that out. Be just a second here to find my Zoom window. It's here someplace. There we go. Let's see. There we go. We seeing that? That should be number 17.
You don't see anything. Not yet.
It's still black screen, but
Okay.
it's coming.
Any luck?
Not yet.
No,
No, the last
still
one we
the
saw
same
was
text.
13, but your explanation was
Yeah.
very good regardless.
Oh, thank you. Well, if we have to, if the rest of this is all text, so if I have to soldier on without it, I will. Let me have another stab at it here. Let's see. There we go. How about this?
Still the same.
Mark, I think
Oh,
you might
great.
have to go out of the Zoom and come back in again.
Yeah, I think. I think
Mark,
might
do you
be
want
right.
me maybe to share your slides and then?
Oh yeah, sure.
Oh, now
let's
it-
do
Here we
that.
go.
Let me-
Yeah,
It's a
now it
PX
works.
Oh,
Oh, hold on. Let's try one more time here. Oh, you know what? It's getting to be 9 o'clock here. I'll bet Zoom is really busy right now. People are cranking things up.
So if you want, I can share it.
Sure, give it a shot. I will stop sharing.
Oh, we missed it there. It was on there for a minute.
Oh,
Try one more time.
story
Okay,
of my life.
so-
Actually, I think what I'm going to do here is I'm just going to do this in a window without the presenters.
Can you
notes and
see my?
Yes, I do.
Now, okay. So which slide?
Hold on. Let me slide that. Give me just a second to slide that window over here.
Here, process boundary.
That's the place.
This is PDF from the wiki, so all
That's
the
fine.
text will be on. Okay.
That's fine. So nothing will be a surprise.
Okay.
So sorry about that. Anyway, so as I said before, every method operates on a process boundary. We actually run an external program to carry these methods out. And that buys us three things. The first is that it allows plugin methods to be written in any language you want, as long as the inputs and the outputs all match up. We use and recommend Python 3 because that's what the rest of the system is written in. And we also have a Python module called pscheduler that's available with a whole lot of classes and functions that do a lot of the things that the plugins have in common. So for us, it's sort of a convenience thing. That doesn't mean, however, that if there's some plugin that needs to be written in C or something else like that, where it's a better choice for it, it's not really a problem. It also lets us evolve the tech stack inside of pscheduler without having to rewrite all of it at once. I can actually rewrite parts of the core, say in Erlang or something like that if I wanted to, and it wouldn't affect the plugins a bit. So there wouldn't be, if we decided to overhaul the technology in the system, it wouldn't be sort of an all or nothing, all at once thing. The second thing, and this is something that was alluded to in Christopher's presentation, it also makes development, test, and debug a lot easier because the run methods, the methods get run individually on the command line with CAN JSON input, and you can kind of look at how they behave and what the output is without having to involve the rest of pscheduler. So you sort of get a nice private little test bench to work on. The third thing is that it protects pscheduler from plugin failures, because if a plugin process dies catastrophically, it doesn't affect the rest of pscheduler at all. Pscheduler is close enough to hear the explosion, but not close enough to get hit with any of the shrapnel. Next slide, please. Okay, this is going to be interesting because it's going to be a little tight. So what I'm going to talk about next are the methods in plugins, and I think let's see. Yeah, there's just a couple of lines missing from this, but unfortunately there are things that are deprecated, but I'll cover them. So test plugins are actually the most complicated thing in the system. The first method is enumerate, which every plugin has, and that's just how a plugin describes itself to pscheduler. The next two are called CLI to spec and spec to CLI, and their job is to take, for a given test, is to take the command line options that you've probably seen when you use the command line interface and convert those into a JSON test specification. Spec to CLI does the opposite. We have a few spots in the system where we like to display the test in command line format because it's nice and compact, and that does that. The next method is participants, and that's where a test figures out what pscheduler nodes are involved. So, for example, if you're doing, say, a round trip time measurement, that actually only has one pscheduler node involved. It's the one that's running ping. The other one is just sort of along for the ride by virtue of having a network stack. On the other hand, say throughput actually requires cooperation between two pscheduler nodes, the one at the source, the one at the destination. So that method's job is to figure all that out. The next one, spec is valid, kind of does what it says on the tin. It just determines if a specification for that particular test is valid. Spec format is something that converts a spec to a standard JSON test specification to text or HTML. We maintain those. We don't actually use them anywhere in the system yet, but they're there kind of for completeness, and we figure some web interface at some point in the future will probably use it. Result format does the opposite. That is something that I'm sure everyone has seen. If you've ever looked at a result on the command line, that's going to be something that was formatted by the result format method. And the last two that you can't see are called limit is valid and limit passes, and I'm unfortunately not going to discuss those because they're being deprecated. As it turns out, their function is a lot better accomplished with some of the things that we offer in JQ. Next slide, please. Okay, tools have a lot of methods themselves. Fortunately, these all fit on the slide here, and those are also pretty straightforward. Enumerate again does the same thing that it does for the test plugins. Enumerate does. The next one, can run, is where a tool gives a yes or no answer about whether or not it can run a given test. So that's part of the shopping the tools around process for determining which tool you use. The next one, duration, figures out how much schedule time is required to run a test. That goes by the measurement and setup time and that sort of thing. The next one is called participant data. One of the things that pscheduler has inside of it is kind of a whiteboard mechanism for all the participants in a test to be able to put information up for the others to see. That gets used in a few narrow cases. The one that comes to mind is iPerf3, for example. The server side kind of scribbles a little note that says what port it's going to be listening to, and the client side looks at the whiteboard and says, "Oh, I need to connect to 5201 or 6108 or whatever it is that the server side says it's going to be where it's going to be listening." The run method is what actually carries out the measurement and produces what we call an interim result. And then merged results takes all the interim results from each of the participants and combines them into the final test standard type result. Let's see, next slide, please. So the remainder of this presentation, I'm going to talk about getting your plugins developed because that's kind of an important thing. There is help available from the development team. I think we lost the...
Sorry, it's coming back.
Oh, okay. Oh, you're using the other ones. Okay. I'll send you a better PDF when we're done.
Okay, thank you.
Sure. So I'll start talking while Ivana's looking for the slides there. So there is help available from the development team. Unfortunately, there is no comprehensive plugin development manual yet. Fortunately, there's actually quite a bit of experience developing these things on the team. I'm not the only one who understands it. As I think Ed mentioned earlier, University of Michigan has kind of been our plugin factory for quite a while, and we are starting to have, Christopher is working on the plugin at SUNET, and there's actually a plugin in development over at NASA as well that may end up being deployed as well. We can give you advice on test design. We know we've been through this. We've kind of seen the pitfalls. And we actually encourage that, especially if it's something that's going to be with us for a long time and it's going to be integrated into perfSONAR. We like to kind of help it get right the first time so that we don't run into any problems later. We can give limited assistance with implementation and debugging. In a lot of ways, we sort of really depend on the people who are expert in the tools that are. If you're doing a tool plugin, we're kind of heavily dependent on the people who understand the tools that they're using. For example. When we integrated, there's a program at Microsoft that Microsoft wrote called Ether for measuring throughput, I kind of lean heavily on people who were using it, so I sort of knew what the ins and outs of it were and didn't have to learn it all myself. And as has been mentioned before, plugins that are of general interest, we tend to adopt, and they become part of the perfSONAR distribution, and that way they become available on every perfSONAR node on the planet, which is actually not a bad thing either. Next slide, please. So I'm going to put in a plug for something that Ed developed over at Michigan, which is called the Plugin Development Kit, or the PDK. And the PDK basically contains internally a bunch of templates for each of the 4 types of plugin, and it generates a skeleton for a new plugin in the pscheduler source tree. So there's just a command you run that says, I want to generate maybe a tool plugin, and I'm going to call it XYZ, and it takes care of sort of the initial setup. What comes with it, buried in the or embedded in the source that it produces, are kind of some follow the number steps for implementation. So it'll say, first you want to implement this, second you want to do that, third you want to do this, and so on until you get to the end of it. And as long as you've carried out all the steps that it develops, you should have a plugin at the end. This works very well on what I call a standard pscheduler development cluster. There's a subdirectory in the source tree, scripts vagrant dev cluster, that has a vagrant file that's real easy to spin one of those up and get to work on it. So if you will hit me with the next slide there, I think I have, I don't know how I'm fixed for time here. I think it might be over just by a minute or two. But I will be around during the next next break if you have questions or anything else like that, or feel free to deposit anything in chat.
Thank you, Mark. Yeah, we will have some Q&A part at the end, so maybe to proceed, unless there is some immediate comment. Was it from you, Ed, or?
Yeah, I just wanted to say that our intern and plugin whiz, Abigail Fox, has improved the documentation and the plugin kit quite a bit. So there is documentation for all of the plugins now.
Great.
Thanks, Ed. So your presentation is next. We can see the slides. Except now we see click to exit full screen. So
let me fix that.
Okay.
Sorry about that.
No problem.
Uh-oh. It says it failed. I'll try one more time here. Sorry. This should do it. So I'm at Colone, and I'm here with my colleague, Craig Maxfield. We're from the University of Michigan. We work for the network infrastructure team under Dr. Eric Boyd. The University of Michigan is a very large distributed campus. We have hundreds of buildings. You can see that we have buildings X and Y on the left-hand side of this graph, and those are clouds because those represent a multitude of buildings, each one of them, and you can see that they're dual homed. So we have redundancy. We have lots of 10 gig links, lots of 1 gig links across campus. Our core has a dedicated perfSONAR deployment, as you can see there in the graph, but it is not economically or physically feasible at this point in time for us to have perfSONAR in each one of these buildings. Now, that doesn't mean that the network in all those buildings are perfect all the time. We have complaints sometimes, and in order to rule the network in or out, we have to come up with some sort of testing strategy. So I want to preface this talk by saying that perfSONAR does not endorse or promote any hardware platform or vendor. This is an anecdotal talk, and the lessons learned are ours, and your mileage may vary. And if you break it, you bought both pieces. So the history of this is that when we did our core deployment, we used server class hardware, rack mount, very capable, kind of expensive, kind of loud with some cooling fans. And when we had a very serious network issue on campus, we took some of these server class hardware to an ancient campus building and tried to debug the problem. And we quickly found out that these were not great sitting on a professor's desk or in the dirt floor of a 100-year-old campus basement. So we needed portability. We wanted to have a small form factor. We wanted it to be cheaper. It needs to be 10 gig. It has to have a perfSONAR supported OS. We don't want to be fighting with that. And there were some niceties we wanted: possible rack mount, out-of-band management, expandability, and x86 would have been nice, but that's not as important anymore because of the CentOS debacle, which we'll talk about later. So we ended up purchasing and evaluating the Supermicro E308D. Its form factor is rather small. A network tech can take a pair of these and easily transport them to campus. They have 2 SFP pluses, so we can put a short range optic in one and a long range optic in the other. It's got multiple 1 gig ports. It's got an out of band management port. And without the optics, with the options that we have elected, they're about $900 a piece. I'm also currently talking with the manufacturer to see if we can shoehorn a single 40 gig, single lane 40 gig card into one of these. So when we get 40 gig on campus, we could still use these. So bootstrapping these is pretty standard. We bring a crash cart with a VGA USB. We set up the firmware and the out-of-band management. We install an OS. We configure the network, and then we quickly use the Ansible scripts that perfSONAR provides to install test points on these. And you can also optionally mess with the limits file. So that way you can tell these to have less restricted testing if you're using some sort of bastion. So one of the tricks that one of our staff, Jeff Hagley, came up with is we use a bonded interface scheme. So when a tech takes one of these out into the field, they can elect to plug in the 1 gig or either of the 10 gigs, and it will just work out of the box. They'll be configured to run the correct IP, and it'll be just plug and play, basically. Now, the problem here, obviously, is that this could be a performance bottleneck, but we have taken it into the lab and we verified that we do still get true 10 gig, even in this bonded interface scheme. So on the back of these, we have the ports that I discussed. We have that bonded scheme. You can see that on the right, where we have the short range and long range optic and the 1 gig. So a tech in the field can go out and plug them in and just be off and running. And as you know, they don't necessarily need an account on the machine either, because perfSONAR works accountless. They just have to have a pscheduler bastion server to tell these source and dest. And then we also have out-of-band management on the A port, and then the D port there, I have configured for DHCP. So if we bring these into the lab, we can plug them into the lab network, and then we can just get on them and get a console and use them without having to extend the network into the lab. And I will turn this over to Mr. Maxfield.
Hello, so my name is Craig Maxfield. I'm from the university, as Ed has said. I'm on the network team here, so I worked with him to get the network side figured out and to put together our plan for how we were going to test the network, test our 1 gig, 10 gig links specifically. So the boxes are set up where we have a dual home setup. So a lot of our locations, for redundancy, have 2 what we call DLs, or the distribution layer. That's where the fiber comes into the building. If we lose 1 DL, if we lose 1 router, the building itself doesn't go down. So this allows us to test any kind of unique situations where we might have 1 DL that's acting up or having problems, one that's not, and therefore we might have an issue where we want to test both DLs. And we can also slim it down so we can test a single DL if necessary. So that's why we went with a /29, which gives us a little more access, or a little bit more IP space. As you can see here, there's approximately 8 IPs in it, 7 usable, or 6 usable actually. between the gateway, the DLs, and the two test points, the two perfSONAR boxes. So we have a lot of flexibility. If we want to just test with one perfSONAR box, say we're going from inside the network to outside the network, we can test with just one. But if we want to test inside the network to staying inside the network, say we have two access layer switches that are having issues, this will allow us to bring two boxes onto site, and they're more than light enough where I can carry them in and bring them around. But I can put them on two different switches, or I can test the same switch. Maybe we have an access layer problem where going from port A or port 1 to port 6, we have an issue there. So we can test within the building, and we can test outside the building to the permanent perfSONAR build that we have, as Ed mentioned. Slide. So we do that by having the networks are like the .72, .80. So what that allows us to do is we have separate IPs built into these that are locked in. So we have like the 72//29 here, this vperf test pair 1. What that allows us to do is we can put .73 and .74 and .75 on the DL. So we would use .73 for the gateway. That's what actually gets us out. We can use 74 and 75, which has to be on the actual building router. And then we can use 76 and 77 for testing the devices. And then that gives us 78 as an extra. 79 is what's called the broadcast. It's kind of a burner IP. You can't really use it. That's done for network specific stuff. And then .80 starts the next one. So what that allows us to do is we can take, if we want to test in the same building, we can put everything on this .72/29 network, and we can test everything that we want to test. /30 only gives you 4 IPs. And so you're really limited at that point because 4, but you still have the network and the broadcast, you really only have 2 IPs. So that would only give you a gateway and 1 test host. And we felt that would significantly limit our testing. Separately, we can also have an IPMI network on there so that we can also test and get the boxes can be reached and gone from there. So we have a bit of a test server. We have a test procedure that we developed kind of under fire, actually. Basically what we do is we build this network at the test site. So we get a phone call and says, building A, chem building or something is having an issue, and we'd like you to come out and test it. So we'll come out there, and the first thing we do is we build the VLAN, we put the /29 on the router or the 2 routers if it's one of those buildings. And then we bring it, or we call it, it's called stretching the VLAN. We bring it to the actual ports that we're going to plug our devices into. All we do is plug in the equipment, power it up, and then we should be able to ping it from the network. There's no configuration. Nobody has to log into the box. Nobody has to configure anything on the box. We then have a Bastion server that's set up, and that Bastion server can go out. You have to know the IPs of the box. So the IPs are listed with a sticker on the box. So you know exactly where you're going. And then after that, you can run your test. And as you can see here, we have a little output that shows that even with these boxes, we can get 9.9 gigabit throughput doing this where nobody has to actually log into the box. Nobody has to, you have to know what test you're running, but you don't have to know the absolute, how to log into the box or any of that. You take your network background. If you have networking gentlemen like myself that are trying to test this, and they can just run the test. Okay. So what we can do is, so here we had an issue over at a Randall lab, and they were saying that they had slow throughput going to a data center. And so we initially started out with the Dell servers, as Ed pointed out, and I had to bring them out there. They're 30 pounds each, and we brought 2. They were exceptionally heavy. So we found very quickly we had a need for a much smaller platform. So what we were doing is we were trying to verify this problem, fix this problem, find this problem, figure out what was going on. And when we initially ran the test, we were getting 10 meg through what should have been a 10 gig connection. And it turned out later on it was switch issues, but we were fighting ourselves because we didn't know exactly where the issues lied, where the issues existed. and we hadn't fully benchmarked or tested our equipment. So next slide. So we very quickly found out you need to test your equipment. You need to really understand what you're doing, what you're looking at, making sure that your devices can see each other at 10 gig. And so what we did is we pulled everything back, did a plug in the equipment next to each other, right directly through into each other, one end to the other, no switch, no anything, verify that they could actually see 10 gig. And then we went from there. Next slide. So what we ended up doing is we then plugged it into the network switch, which was a 10 gig capable switch. And it allowed us to figure out what was going on there. And we started realizing that that's where we were seeing initially when 10 gig throughput. We then brought in, we field replaced the switch that was on site, and the switch that we brought back was seeing the 10 meg. So that's how we were able to verify that that particular switch was seeing 10 meg, which was actually tied to the Dell switches. I don't want to go into the weeds there, but there was some communication issues, some protocol issues between the two, and that's why we were seeing the 10 meg. The on-site issues were actually completely separate. But this allowed us to test on the same network, a fresh, new, unboxed, never plugged into the network switch. So we were able to validate that testing. So now this is more of what we're trying to do with the super micros. The super micros here, as you can see, one's plugged into the DL, one's plugged into the AL. So again, the DL is the building router. Think of it like a cable modem at home, where you get a connection from your internet provider, and then you plug your wireless router or whatever your equipment is into that. And the AL switch is kind of like that home broadcast router. It's providing access, it's providing network to your devices in your house itself. So what we do is we can take one device, plug into the DL, one device plugged into the AL, and we can start testing inside the building, either on the same network, or we can do different VLANs, different networks, and test the routing of the DL. And we can test whatever we need to test at that point. We can also go outside the building at that point, and we can go to the core. We can test that the core is operating just fine with the uplink from the DL to the core. The downside of that, of course, is you're still limited at your slowest speed. So in this case, it would be a 10 gig test. As Ed said, we don't have 40 gig testing capabilities yet on these super micros, but that is something that he is working on and something that we hope to have in the future. But this would allow us to, well, this is just a temporary thing. This is hey, we got a phone call that the network is slow. We don't want to install these permanently, at least not today. So this would allow us to just validate testing and see where the issue is, see what the problem might be, because until you know where exactly the problem is, you can't fix it. And user perception issues are by far the biggest thing that you want to fight, because if your network is super fast, but somebody thinks that it's really slow, they're going to call it really slow. Even if the problem lies outside of our network, say someone's trying to download something from another external website and they've got a really bad connection themselves, they're going to blame our network, because they're going to say, I'm plugged into your stuff, it should go faster. So we always want to fight that. We want to test that. We want to verify that. We want to validate it. So next slide. I think you went one too far back there, Ed. Skip one. So as I was saying, if eventually we want to test the entire network from the switch that the user is connected to, and we could even put the super micros, we can put them right on someone's desk. They're quite small, very quiet. They are, they don't take up the entire desk like the Dell server did. And if we want to, we can also plug them in outside of their desk. We can bring it to our closet where the switch actually lives, and we can plug it into a similar port. We can build it so it looks just like theirs, and then we can test from ourselves to wherever on the UM network, or even outside the UM network that we want to test. Say we want to test that our internet connection is allowing this user to get to 10 gig. Make sure, say that there's no problems, we can test outside of U of M. Again, we're still gonna be limited by our slowest speed, which a lot of our switches have 1 gig, so we'd only see 1 gig if we were testing that. Alternatively, for all of our fiber switches, connections where we have fiber to the desk, those are 10 gig. And so in those instances, we would be limited both by the uplink to those fiber switches, as well as the 10 gig capability of the Supermicro, which is why the Supermicro is great for testing user connectivity. It's great for testing connectivity where an individual or a group of individuals is saying they have an issue, but I don't necessarily recommend these for our servers having a problem, because a lot of servers can be connected faster than 10 gig. And inside our core, our core, as mentioned here, is 100 gigabit. And so we're not going to be able to test inside the core with these Supermicros, but we would be able to test, hey, my 10 gig server is having an issue, as long as that's the actual connection speed of the server. If their connection speed is 20 or 40 gig, we're not going to test that with these.
So this is sort of the conclusion of our talk. In these slides, I've included some links. There's a link to a spreadsheet that we use to manage this system. You're welcome to make a copy of that and use it for your own. We have a little bit of instructions for the CentOS bonding side. There'll be another talk about perfSONAR OSs. We'll probably move to Ubuntu at some point. There's a limits tutorial, the Ansible playbook, and some information about the Supermicros. So I hope that you guys have enjoyed the talk, and if you have any questions, we'd be happy to field them.
Thank you, Ed. At the moment, we do not have any questions in the chat. Yes, Mark said that a newer version of the presentation is on the wiki. Are there any immediate questions to Edward and Craig? If not, then we can proceed with the next topic. Mark and Antoine will talk about CentOS and OS support.
Yes, thank you, Ivana. Yeah, this talk will just review what we are doing in terms of OS support, and in the specific case of CentOS, more specifically. So as you know, probably or may not, but is a quick recap on that. perfSONAR is running on different OSs. CentOS is the main one, and that's what we support for a long time, actually, probably since the very beginning of perfSONAR, although I cannot remember the first and second version, but at least from version 3. This is our main development OS as well so far. And then some years ago, we started support for Debian and Ubuntu, and also some derivatives of that, but as Raspbian, as we've seen today. So that's what we have, but things are getting different now. So I'll hand over now to Mark.
Thanks, Antoine. So I'm going to talk about the current state of things in CentOS. Next slide, please. Okay, not a whole lot to say about CentOS 7. We've supported it for a long time. Its end of life is June 30th, 2024, and we have every intention of continuing to support it until then. So that's pretty much all there is to say with that. Next slide, please. So if you haven't been living under a rock, you've probably heard about what's happened with Red Hat over the last couple of years. In July of 2019, IBM acquired them and is now their new owner. And at the end of last year, they announced that CentOS 8 was going to reach end of life December of 2021, which of course is this December. And that's 8 years of its originally scheduled date of 2029. So that was kind of a little bit of a shocker to everybody. Next slide, please. Their proposed replacement for it is called CentOS Stream. So what we used to have was a path where there was Fedora. Fedora would inform the development of Red Hat Enterprise Linux, and then from that, CentOS was derived. So what you got there was an operating system that was derived from very stable enterprise Linux code that wasn't released all that frequently. What CentOS Stream gives you is a new position. It puts it in between Fedora and Enterprise Linux. That happens even ahead of the Enterprise Linux development. There are rolling releases, and sort of I think a lot of people out in industry have basically said, well, great, welcome to the Enterprise Linux beta program. Needless to say, that's not the kind of thing that people running production systems are really interested in having. Next slide, please. There are a bunch of alternatives to CentOS 8. This is kind of a short survey of them with some things that we as the development team find interesting. There is obviously Red Hat Enterprise Linux. Costs you money to have. It is very stable, and it's available in general release. There's no community development going on. CentOS Stream solves the free problem. I suspect that it will probably largely be stable, but it's not really based on what's being released as stable code. But again, it is available in general release and kind of has the same problem. It's not community developed. There is Oracle Linux, which has been around in various flavors for quite some time. That is free. It is based on the stable EL code. It is in general release, but it kind of has the same problem that the Red Hat flavors do, in that it's kind of under corporate control. Immediately after the CentOS 8 announcement last year, there was a lot of buzz surrounding a distribution called Rocky Linux, which is going to be free. It is going to be based on stable code, and it will be developed as part of a community effort. The problem is that it is not in general release yet, and the people maintaining it have not even projected a date for it. So that's kind of vaporware for the moment. There is another distribution that has appeared recently called Alma Linux, and I'm going to talk about that. Next slide, please. I'm going to talk about that specifically because it does actually check all four of the interesting boxes. It is free. It's based on the stable enterprise Linux code. It went to general release just a few weeks ago on the 31st of March. It is a community development effort. It's backed by a nonprofit foundation that is receiving $1 million in annual sponsorship from Cloud Linux Inc. Internet 2 is actually deploying Alma Linux on the systems that we put in our POPs for our next generation infrastructure project. Those machines are out there. They're spinning. They're not quite into production yet because that network is also not in production. But each one of those is going to run 200 gigabit perfSONAR nodes in Docker containers, and we've tested all that actually works, and our internal network management applications. This is obviously not an endorsement on Internet 2's part, but the folks who've fielded it so far say it feels exactly like CentOS 8, and they really think that so far the Cloud Linux people have their acts together. So next slide, please. So that sort of brings up the question of what's the future of perfSONAR development on Linux that's derived from Enterprise Linux. Currently, CentOS is our primary development platform. pScheduler has been ported to CentOS 8, as have a few other parts of the system. We are doing some work to bring Debian into equal standing, Debian, and of course, its derivatives like Ubuntu, so that we can sort of switch from one to the other. For pScheduler development, I actually have some things that may show up in 4.4 that will let you do development on either, and it'll sort of, for developers, it'll still be kind of the full experience. What's really important, and Antoine is going to talk about this some more in the rest of the presentation, we really, really need your input to make decisions about where we go in the future. It's important to us to know what your organizations are thinking as far as where you're going to go, whether you're going to stay with CentOS or one of the derivatives, or what you're going to switch to, and just kind of where you'd like to see things. So with that, I will turn it back over to Antoine.
Yes, thank you, Mark. Well, just before getting back to you and asking for your feedback on that. For the sake of completion, I will just give a brief overview of what we do with Debian and Ubuntu support. So far, and at the moment with the current release, we fully support Debian 9, Ubuntu 16, and Ubuntu 18. So that means that all the perfSONAR packages and all the perfSONAR bundles that exist can be installed on these three OS. And we currently only support the test point bundle, and that means also the tools bundle, but that's really just the tools. But for the test point, you have a pscheduler running, so you have a fully working perfSONAR node just without the graphical user interface. And the test point is supported now on Debian 10, as some of our presenters already said today, because Raspbian that's used on the Raspberry Pi is based on Debian 10, and will be offering Ubuntu 20 support shortly in 1 or 2 months, hopefully. So that's what we support at the moment, and we're not able to support the toolkit on Debian 10 and Ubuntu 20 at the moment, because we still have SMOND, and SMOND is dependent on a Java 8 runtime engine, and this is not available for Debian 10 and Ubuntu 20, as it's getting quite old. What we think will be discontinuing shortly is support for Debian 9 and Ubuntu 16, as their end of life has been announced and is coming close. But that's, yeah, we're looking at that for perfSONAR 5. So I'll be talking about a bit more about that in a few minutes after this presentation, in the next presentation actually. So with perfSONAR 5, we're looking at having support for Debian 10, Ubuntu 18 and 20. So as Mark said, what we like to know now to make decisions on which OS to support in the future, and how to serve you best, we'd like to know what are your preferences in terms of OS usage. For that, we have prepared a poll on menti.com, so you can go to this URLs, menti.com, and enter the code that's shown below. We'll switch over to the actual presentation of menti.com. So you can see here on the top the code that you need to use. You can go there with your browser from your computer, or even from a different device. It works well also on smartphones or whatever you want to use. So we have 6, I think, yes, it's 6 different questions, and yeah, it's a way we'd like to collect your opinion on that. So that's interesting to see that quite some of you are running perfSONAR on an unsupported OS. That's good. Some on Ubuntu, some on Debian, and yeah, half on CentOS at the moment. And are there more opinions coming in? I'll wait just a bit more. Yeah, Ubuntu 16, still some running that. Okay, that looks good. That's quite diverse, I would say. So let's go to the next. Let me see. how do I go to the next here? Like that, yeah. So the second question is, which OS is your organization using for all the other server deployments you're doing on your network and on your appliances? So we would like to know probably what, probably in a large organization like the organizations we're working for, it's easier to support a smaller set of OS rather than a lot of different OSs. So it would make sense to be able to run perfSONAR on the same kind of system that you usually run your servers. So Ubuntu and CentOS are the main one. Actually, probably CentOS 7 is the main distribution used. Some of you are already using CentOS Stream. That's interesting as well. Cumulus Linux, FreeBSD, Windows. Well, good. Let's go to the next question. So if you're using CentOS at the moment, have you already thought about replacing it? So if you're using, or don't you want to use it to replace it, or are you happy with CentOS Stream that is the way it's coming along?
I'd like to speak to whoever's running OS 2.
Yeah, Ubuntu and Debian seems to be common choices, but clearly some of you don't know yet. Yeah. Anyone from CERN here? Okay, let's go to the next question. So if you think moving away from CentOS, how urgent do you think it is, and how urgent would you like to have perfSONAR support for a different OS?
It says it's not open for voting. Is it just my end, or?
Oh,
Same issue here.
Voting. Is it now?
No, not yet.
I just got it.
Yes, but I had to refresh the page.
Okay, sorry. Probably did a misconfiguration on that slide. So we are balancing between a few months and a few years. So that administration.
I think it should not be such urgent, because we have CentOS 7 has time support till the 2024.
Okay, let's go to the next question. And if you could choose, what would be your preferred OS choice for perfSONAR, for running perfSONAR on? Yeah, so this is quite diverse set of answers, but Ubuntu seems to be coming frequently. Alma Linux, Oracle Linux, as well, FreeBSD, yeah, and Plan 9. Okay. I guess we need some Plan 9 developers joining the team. Maybe we already have, I don't know. Okay, then let's go to, I think, the last question. So what do you expect from us, perfSONAR developers, in terms of OS support? Just an open question, so feel free to shout whatever you want. Yeah, all interesting suggestions. Yeah, avoid OS locking. Good. Well, then I think that's actually the last question to this short poll. So thank you all for participating and giving us feedback on those questions. We will compile all that and try to take all that into consideration. We cannot support every OS suggested, as you know, but we'll surely take all these answers into consideration. So that's it for the CentOS and OS support presentation. And unless there are some questions, I haven't looked at the chat, but I will switch over to my presentation with the roadmap.
There were no questions in the chat, Antoine. There was just a comment from Andy about the historical part related to operating systems. Andy, do you want to say that instead of me reading this out loud?
Oh, no, just Antoine was wondering, he had made a comment that he thinks we'd been on Red Hat for quite a while and wasn't sure if there was anything before. So I was just augmenting that when I joined the project over a decade ago, we were actually on Knoppix Linux, and the live CD was the only distribution we had. I think Knoppix is Debian based, but yeah, it's only for basically live CDs, which are temporary media. And yeah, so that's all. I was just adding that footnote.
Good, thank you, Andy.
Thank you.
All right. Then I will go over to my next presentation, which is about the perfSONAR development roadmap, what we are looking at for this year, what we are currently working on, and what you can expect from us in the coming month. So what we are currently focusing on and what we trying to address as developers going forward is to focus really on where perfSONAR brings value. So we would like to reduce the effort we spend in maintaining a lot of different packages, and we'd like to, wherever possible, switch to open source packages and open source solutions, libraries, middleware, whatever that already exists and that can be suitable for integration with perfSONAR. So we've been in touch with a lot of users in the past years, and we've watched the main perfSONAR deployments, the largest one, some work that's being done in projects like WLCG, and some other large deployments, the tools they are using. And we've seen there some possibilities. So that's what we like to move on in the coming release. We'd like also to take care of the technical debt that we have with some components that are really depending on very old version of open source packages like ESnet, which at the moment is depending on a very old version of Cassandra that's not supported anymore, and porting it to a newer version would require quite some work. So with that in mind, we think it's time for perfSONAR to change its backend, and actually changing the backend will open up possibilities for changing the front end as well. So when we are thinking about perfSONAR 5, we'd like to replace ESnet with elasticsearch and Logstash, which are components that are widely used in our communities, we think, and that are also well supported by their respective development communities. And if we replace the backend with Elasticsearch, we know we open up possibilities for visualization, be it with Kibana or Grafana, or maybe some other front end that are available as well. And opening up the visualization possibilities also open up the possibility to merge different data sources into the visualization layer. So with a tool like Grafana, you can include data coming from InfluxDB, from other kind of database that you are probably running already in your environment, in your deployments in your organization. And that's we think that's really something that would bring value to perfSONAR in the future. So if we try to put that into a bit more details in what will happen this year, we're currently working on perfSONAR 4.4 and maybe a 4.5 with some minor new feature and improvement to pscheduler, to the toolkit UI, like we've done in the past month and the past 2 releases actually, and to bring in Ubuntu 20 support for the test point. So that's releases that are coming, that will be coming close in the coming month. And then we are looking at perfSONAR 5.0 to bring in the replacement for the backend. We'll not be replacing both the backend and the front end at the same time. So we've actually a prototype, and we're now developing the beta version of an ESnet API compatibility layer. So that means that all the tools that we have at the moment that depends on ESnet will be able to continue to run with the Elasticsearch backend. So that's Mapdash, that's the toolkit web UI. That means that also for you, for you perfSONAR users, it will not be a big bang change, and you will not need to relearn everything from scratch about perfSONAR. We will first change the backend, and with that opening more visualization possibilities. If we try to put that on a time scale for better understanding of what will come in this year, so we are looking at having perfSONAR 4.4 released this spring. A beta for perfSONAR 5 by the summer of this year, and then hopefully the production and final release in fall of this year. And then from then we'll be building the new visualization layer, providing new UI feature and building new dashboard, probably in Grafana. So something to replace Mapdash, and as well some improvement to the lookup service and other things like that. So that's what, yeah, the current roadmap for the coming year. And I think that's all I have about the roadmap. And maybe a reminder now about perfSONAR that we want it to be a community, so we welcome your feedback, and we actually need your feedback. Without your feedback, we do not know what we should focus on, what we need to work on. So we need your help with that. So we're trying again to engage more with you, and we have some events coming up next this month and in May and June as well. So you're welcome to attend and assist all these events that are listed here. We also welcome your feedback in the different channels that we use and that hopefully you already know. So on the users list, with the documentation and the website that we have. We have the YouTube channel where we collect all the videos and webinars we've organized in the past. And if you're inside the GÉANT project or under the GÉANT project area, you're welcome to get in touch directly with our team in GÉANT, the Work Package 6 Tasks 3 team, with the email that's listed here on this slide. And this, I think this ends my presentation about the roadmap. If you have any question about that, I'm
thank you very much, Antoine. There is actually a question in the chat. Jan, do you maybe want to ask it yourself?
No.
Okay, so Jan asked, after this encouraging talk, how do we participate and not just use?
So if you want to participate as a developer, you can also write, that's a mailing list I didn't mention here on my slide, but we have a perfSONAR developer mailing list. So if you replace the -user with -dev at the end, you will go to the developer list. It's a moderated list, so if you're not subscribed to it, you need to get approval and your message moderated first. But we're welcoming any participation. So get in touch with us through the mailing list or through GitHub as well. So if you have you want to submit patches, pull requests, there is the issue tracker on GitHub. So we welcome also feedback and contribution there. And if you're interested in working in one of the area where we want to focus our development now, we'll be happy to speak with you and to know how you want to get involved.
I would add to that too, that we just, there's not only do we need, can we use help with code development? I mean, we have, we have a lot of documentation that some of which could probably use some sprucing up. So if you're into writing stuff and you understand how to operate perfSONAR, we welcome that sort of thing too.
Excellent. Any other questions or comments? If not, thanks to all the presenters. We are now approaching our next break. So the break will be until, let's say, in 15 minutes. It is 4:10 Central European Summer Time. And we will then resume with the final presentation and wrapping up. Thank you. Looks like it's not. Okay, it is now.
Okay. It's already there.
Yes, thank you very much. Yes, please start. You can start.
Hi, good afternoon to all and good morning to those attending from here in the US. And I'm Sowmya Balasubramanian. I'm a software engineer at ESnet, and I've been associated with the perfSONAR project since 2010. And I primarily work on the perfSONAR lookup service. So before we go into the actual talk, a brief overview about ESnet. ESnet is Energy Sciences Network, and we are the US Department of Energy's high-performance network, and we are optimized for enabling big data science. So what that means is we provide connectivity to various DOE national labs, various experiment sites, and supercomputers. So what is the perfSONAR lookup service? So we are familiar with the toolkits, and they are capable of running, these toolkits are installed in various places around the world, and they are capable of running tests to each other. But when you want to run a test to a particular toolkit host, how do you discover? And that is where the perfSONAR lookup service comes into picture. So the toolkit hosts, if they are available for public testing, they register themselves with the perfSONAR lookup service. And when users want to find them, they go to the service and look up this information. And so if you actually take a look at the overall software, typically a toolkit host has some combination of the pscheduler tools, archiving, and the various visualization tools. And if you're doing a central management, you're probably having some psconfig as well. And if you look at the lookup service, it actually doesn't get really installed on the toolkit host, where instead the toolkit hosts only interact with the lookup service. So it's a standalone, its own separate entity, and it runs as a separate service, and the toolkit hosts go and often interact with the lookup service. And all the data that is available in the lookup service can be visualized in what we call as the ls services directory. It's basically a simple Python web app, and that's actually running on stats.es.net. And I've provided the URL for it. And that is where this particular map comes from. So it shows all the various toolkit locations. And if you click on those dots, it'll actually bring up the details about that host. In addition, this particular web app also has a search feature. So you can actually do some simple searches based on keywords and few other parameters, and it'll show a list of hosts that match that criteria. So to give you a quick overview of what does the lookup service contain. So as it runs today, it is actually a simple instance. it has a REST-JSON API as its front end, which is written in Java. And then it has a database, and today it is Elasticsearch as its backend, but it can be pretty much any key value store. And currently it actually runs in a virtual machine in Google Cloud. But before we go into the details about the lookup service and some of its features, I just wanted to quickly give you an overview of how the lookup service has evolved over the years. So the version that we know as the REST-JSON based one, which is a simple lookup service, was officially released sometime in 2013. And at that time, it had MongoDB as its backend. And the deployment model was a little different. So we had quite a few instances deployed across the world. And that was because it was following the model of its predecessor. And and we ran this for a few years, and there were some learnings along the way. And so basically one of the big things we noticed was, now when we have these few instances, the data was fragmented, which meant in order to look up an information about a single host, the query had to be targeted to all the instances, which meant sometimes if the instance was not available, then you had inaccurate information, or sometimes there was duplicate information because these toolkit hosts detected that that the nearest instance was down and it was trying to register to another instance. So there was all these different issues. And so that's when we made this decision to consolidate the instances into a single instance. And at that same time, we also made the decision to move to Google Cloud. And around that time, there was also an effort to refresh the lookup service requirements. Because the previous time we had done that was sometime in 2011, 2012, when we started the implementation of this REST-JSON based version. And so it had been a while, and there had been some learnings along the way. And then once this REST-JSON based API was available and users started using it, we got some feedback on like some of the other things that they would like to see and all that. So based on that, we refreshed the lookup service requirements. And after that, like pretty much from the move to Google Cloud and everything else after that is kind of based on the new or the updated set of lookup service requirements. And so the other big milestone was last year. And so last year we replaced the MongoDB backend with an Elasticsearch backend. And now that it has been running for a few months now, it has been stable and reliable. We are now starting to look at improving leveraging some of the capabilities of this new Elasticsearch backend, and improve like the APIs, do some data validation, and so on. So to give you a quick overview of the LS requirements. So basically, the detailed version is provided in the link in this presentation, but the requirements can be classified into 4 main areas. So one is around data and APIs and things like improving the query response time, improving the query features, and data validation. All that comes under that focus area. The second main thing was around improving stability and the reliability of the service, so which meant we needed better monitoring and alerting. And then the third thing, which was the security. So this was something that we didn't specifically get it from the community, but this is something we wanted to provide on a proactive fashion to the community. And then the final one, which was around architecture and deployment. And one of the biggest points there is that we continue to support private LS. So if an organization wants to deploy the same instance, but only for their organization, we do support that model. And then the other big one was we need to ensure that it is easy to, at some point, if we wanted to switch cloud providers or even move to on-prem, the deployment model supported that pretty easily. And so since then, there have been quite a few features that we have developed and released. So one of the big ones is around security. So this was released, I think, probably about at least a year and a half ago, sometime in 2019. And we basically support the digital signing of records. And so this feature is actually currently available in the toolkit itself. So there's a particular feature or a particular flag that you need to enable, and the lookup service, and if you've provided a key with it, so then the lookup service would actually, before registering the records, it would actually do add a signature and then register the records. And similarly, if you've turned on the verification as well, then before doing the renewal or before doing any other operations, the lookup service can actually look at the signature, and if it has a public key associated with it, it can actually verify that signature. And currently, the way we are thinking is you can make, you can exchange the certificates out of band, or maybe even register with the LS if you would like to. So the security feature is pretty basic, but we wanted to start here, and as you know, as we move on, we'll probably add few other capabilities. The second area of focus was, after the requirements were refreshed, was the improving the APIs. And one of the things we did there was to support bulk renewals. And so now, so this basically was, this makes the communication between the toolkit host and the lookup service efficient. And so instead of sending a record for every type of information that the toolkit host registers, now all that can be, so it's still, it does send the different records for each of the different types of information that it registers, but it's all combined into one single operation. And then the other big one, which I did mention before, was we replaced the backend with Elasticsearch. And the main driving factor there was because Elasticsearch also has a REST JSON, and it has, the query has a much richer feature set. So there are a lot more things you can do with the query API of the Elasticsearch. And so when we wanted to leverage that capability, because the query API that the lookup service has is, we can do some simple keyword filter-based searches and stuff, and some very basic wildcard support is there. But rather than just duplicating that same effort, we thought of just leveraging Elasticsearch if we could just expose that particular API. So if you look at the lookup service today, we still have the registration, renewal, delete, all the edit or any kind of changes, those kind of operations still go through the lookup service API. We also have the query API. It's not mentioned here, but it's also there. So you could continue to use the lookup service as before. But in addition, we also have exposed the Elasticsearch REST API, so which means we have just exposed the GET operations. And so you can actually use that for creating searches that would answer some of your use cases better. And so what's next? So these are the things that we have developed since like 2018, but what is next? So now that the Elasticsearch has been running, it has been stable and reliable for quite a few months now. So now we are thinking about leveraging the Elasticsearch and start leveraging some of the capabilities there. And one of the first things we are thinking about doing is focus on some data normalization and the cleanup of the data, and then start thinking about doing some analysis. And so one idea there is we are thinking of using Logstash and Elasticsearch together. So it's the Logstash is part of like the ELK stack, Elastic, Logstash, Kibana stack. And so they are well integrated with each other. And so the idea would be to build these Logstash pipelines that take the data from the lookup service, they normalize it and write that data to a different index in that same Elasticsearch. And once we start collecting snapshots, then we have potential to perform some rollups, do some transforms on the data, and those kind of things. So the potential is, there's a lot of potential in this. And you might be curious, why Logstash? We can do some of these normalization directly in the web API itself, and that's true. But the idea is we didn't want to touch the production LS too much. And if we tie it to the release cycle of the production LS, then it's going to be a much slower process in the sense we need to validate that things are stable and all that. And right now we are still in the exploring stage, experimenting, and we wanted a way where we could make those changes quickly and look at have users provide us feedback quickly. And so this Logstash model works, fits that way pretty well, because now we don't have to touch the production instance, so that will be running as is. We just take that data, we do the transforms or whatever actions we want to, and we just write it to a different index. And so some of the initial goals, so this is something that has a lot of potential. So at first we would just want to constrain it to a few things so that we can actually get something out. And so the initial goal is to create a pipeline that reads the data from the lookup service periodically. It would normalize and write that normalized data to a different Elastic index. And we need to, and when I say normalize the data, we would be selecting at least like a subset of the current set of fields, and we would try to clean that up, or if it's a, let's say, if it's a capacity field, we would, instead of having everything as a string, which is how currently it is stored in the lookup service, we can actually convert it to a number format and stuff like that. And then the next thing would be, once we have this pipeline, we would make it available to users and have them experiment with it, give us some feedback, and see what they find useful, and start focusing on those set of features. And then in parallel, I think the plan is to start collecting some periodic snapshots of the LS data. So now once we collect that snapshot, we can start doing interesting things with it, like build a timeline or look at the history of how a particular host changed over time and those kind of things. And again, we can experiment with summary queries and those. So the potential is limitless, but the idea is at first to start with a simple normalization pipeline. And then the second one is to start collecting the snapshots. So those are the two main goals for us. And the architecture, it's pretty simple. So the lookup service, this is the production lookup service that would, we wouldn't really make any changes there. Instead, there would be a cron job or something that would actually periodically trigger the Logstash pipeline to go collect the data from the lookup service and make the changes and then write it back to Elastic. Even though this is here a separate logical block, in theory, it could actually basically share the backend with the perfSONAR production instance itself. And some prior work that has gone in this field is, so in fact, GÉANT actually did some work to normalize and analyze the lookup service data. And this was actually done in Splunk, I believe, at least like a few years ago. And those findings and report has been shared with us. And so we will be taking some of that and we'll factor that into the Logstash pipeline as well. So current status, so right now, this is at proof of concept stage. We were able to build a basic Logstash pipeline that reads the Elasticsearch. We were able to pick like 2 or 3 of the fields and get it to normalize and write to a different index. And so right now, this is where it is. And so some of the next steps for us is to complete this pipeline by taking more, few more fields and then also start taking the snapshots and then make this data normalized data available to our either our users or developers and get some. At first, it would be to the developer community, and then we would start circulating it to the user community, start getting feedback, and based on the feedback, we can actually start making changes and start developing features for this Logstash pipeline, and think about it from more like how do we sort of support it as a production or a product that would be fully stable. So, and I think that's basically what has been planned for the lookup service, and what are some of the things we have developed since the 2018 when we refreshed some of those requirements. What are some main features we developed, and what are some things in store are, so I was able to share that. And at this time, if you have any questions, I'm happy to answer them.
Thank you very much, Sowmya.
There is one question in the chat from Olaf. Maybe you want to speak up, Olaf?
Oh, let me.
Yes, I wondered, why is the lookup, the map that is based on lookup service, so slow? Is it because of the response time of the lookup service, or is it some other map technical stuff?
So yeah, so basically there is a so the Python web app itself is a little bit slow, and there is actually plans to improve that thing. Now that we have this Elasticsearch, there is a plan to rewrite it. So we did have a summer student who actually re-implemented and gave us a new this thing, but that needs to be cleaned up and made available. But that's actually in the works.
Mm-hmm. So your experience is that the Elasticsearch lookup times are fair?
So two things. So yeah, so the Elasticsearch lookup time plus the other factor is now it's only a single instance. So all the data is available in one place. So the combination of the two things together does improve the query times.
Okay, good.
Any other questions or comments? If not, thank you very much, Sowmya, for your presentation, and also excellent timing. You were just on time. I will then start with the final part, because we will also have a little Menti during this final session. So I'll share my screen now. So during these 2 days, we actually had 70 participants participating in both days. Most of them were present first day, and most of us that joined on the second day were both days present. So there was just very few people that attended in only one of those 2 days. So we had 15 presentations from 11 organizations, and the whole workshop was organized in 2 days, in 2 sessions. The first day was dedicated to presentations from users to the whole community, and all the developers were listening very attentively to see if any of these things could be taken as some suggestions and recommendations. And the second day was more from the developers to users and to community. So from all these presentations and discussions, there is several recommendations and suggestions that we recognized. So we would, of course, would like to hear very much if any of these things are maybe not very well interpreted, or if we've missed any of these. One was related to improvement of PerSONAR installation documentation, either to make it more detailed or more specific in some elements, then to provide support for layer 2 measurements, for Wi-Fi monitoring, then to include .1x authentication in PerSONAR, to provide a little bit more of data analysis, possibly with artificial intelligence and or machine learning. Then also to related to different operating systems that PerSONAR might support. So we would like to understand better if there are some things that are more important than others, or if you might have some additional information. So I would like to ask you all now to visit Menti. I will run it now, so then you will see the code once when it is initiated. So I hope you can see the presentation, the Menti now. So all the questions are created in freestyle. Sorry?
Not yet, Ivana.
Not yet, you can't see it.
Could you drop the code in chat, please?
I can say.
Yes, I will. Yeah, sure. So the URL is the same, menti.com. So let me see now.
Pretty much telling you now what it's going to say.
Maybe I need to do something else. Just a second.
So they've got cracking, they involve it's 1990.
Is now better? Oh, yes, you can see it. Great. And so, so the questions, as I said, are open. So please answer like yes, we would like to see that, or no, or as you're writing already, more suggestions about some specific topics that we might look at. Obviously, it is something that can be improved. And as it was mentioned today, Mark specifically mentioned it in the talk and in discussions, we would, of course, be very happy to have more contributions from people that might not be members of our development or training teams. Because actually, when somebody is doing the installation, then they might better recognize which parts might need more information. So if you are willing to contribute in that way, please let us know. Also, yesterday we sent some links, and this link will also be repeated in one of my later slides, where you can report which part could be better explained. So far, comments are about more step-by-step guides. Yes, make sure that the documentation is based on a clean machine. This is also good. Okay, so the next question is related to the second recommendation. Okay. And
we don't see you sharing anything, if that's what you wanted to.
No, I'm
do.
not sharing it to the. Okay. Sorry. Yeah, I'll do that now. Just a second. Can you see it
Better now? Yeah.
Yes, and can you reply to this, or is there something else with? Yeah. Okay. Good. Yes, all sorts of new measurements are good. This is true. However, the thing also is on how to prioritize different things. Mark also mentioned what different options exist already in the system, and obviously focusing on some of the options more than on the others would depend on a use case. This is why in the team it is usually looked at based on priorities, like when partners or users are asking more for some options, then they are higher on the priority list, let's say. So the next question is then related to the next recommendation, and this is should we work on measurement data analysis? So Szymon presented today that we have started to look at the measurement data that we have in PMP. However, sometimes finding the right question that needs to be answered is the most crucial part in order to see which data are relevant, where to find it, and how to actually extract the information out of this. So, for example, if you have any such questions that you might consider important for your network, is also something that could be looked at. Related to this part in PMP, we were considering things like, okay, let's see what AI can tell us based on the data. So this is, let's say, the basic approach, but another approach might also be to actually try to find the answer to some specific question, like, will my network as is be sufficient in this period of time, or something like this. Yes, this is very true. This first comment, that can be a very network specific problem. It is very hard to provide some generic things and expect that it will work in each and every solution. Can we all share persona data? This is also an interesting question. And there are at least two aspects of it. One is technical, how to do that, and another one is the reasoning behind this. Why would something be done? So if a reason is strong enough, then usually this technical part is then easier dealt with.
If I could, Ivana,
yes,
if I could throw
please.
in something real quick. There is actually, the performance working group actually has a subgroup going that meets once a month that actually deals specifically with sharing data. There's already a handful of universities, I think it's about a half dozen, that have basically a sharing agreement in place for certain things.
You know this person, Ivana, it's Joe Breen. He's presented,
yes,
I think, at our events before.
Yes. This is an excellent point, Mark. Thank you very much. I'm not sure if you can find somewhere fast some link. I'm sure that Joe has some pages, some generic pages for other participants in this call. I could find it, but I'm sharing my
I'll paste something in. I'll paste something
yeah,
in the chat.
yeah. Because I fully agree with you. This is an excellent group, and also this topic is very relevant, and they have some tangible things that and practical things that are already in place. So it's not like talking just in general. This is something that is really actual and accurate. Thank you very much, Mark, for this comment. Then the next question is related to the implementation in SUNET. In our case, in GÉANT project, this was the first time that we actually saw this and actually that we received such a interest for this implementation, and we found it very relevant and important. And of course, the way how SUNET implemented this is very good. So this is why we would also like to hear opinion from other participants in this call. Is this something that is urgent for you, or as we saw, not that big priority? There will also be another question related to SSID and BSSID.
What are you doing, more like?
Sorry.
Darren, your mic's open.
Oh, my apologies.
Okay. Okay, let's move to the next question. So, perfSONAR for Wi-Fi monitoring, University of Michigan has progressed in that area very well, but how relevant is this for other participants in this call? This also comes to some other questions like how things are, what is used for Wi-Fi monitoring, but let's say this is probably a topic for some other event. And actually, we might consider organizing some event about Wi-Fi monitoring in general, not just related to the tools that we have like perfSONAR and Wi-Fi Mon, but also to look at different solutions that our UNRANs are using. Then the next question is related to the previous topics. Okay, so far not many comments related to this. We have just a few more. And the last one, I believe, is this one. This is related to Raspbian as a supported OS for perfSONAR. Antoine did have another Menti related to OS support in general, so only this question is related to OS in this Menti, but of course we will analyze all the other inputs within the group, and of course the perfSONAR development team will take this into consideration. So at the end, with the last two questions, we would actually like to hear from you. How would you prioritize all of these topics that we said? We've seen for many questions, yes, of course, but organizing this across the team and on individuals and their other tasks might not always match the same view from users and developers. So this is why we would like to hear from you for those 7 topics that were mentioned so far. What would you say? What is more or what is less important for you? So these current numbers are based on the order of how these questions were actually asked. But I hope that very soon we will see your view on this, what is actually a priority. So looks like documentation still stays on the first place. And then it is persona measurement data analysis, and then additional features that could be added in persona.
Yeah, just one comment for those of you who feel that the documentation is missing something or have suggestions. Please do not hesitate to open a GitHub issue for these specific items, because then it will be much easier for us to track that and maybe prioritize and work on that. And yeah, and we'll know what you exactly are expecting from us to improve or to change.
Yes, of course, because of course it can be seen from different angles what we consider to be well enough or not detailed enough. So definitely the more specific inputs that we can get, the easier would be to address this. And the last question is actually related in a way in the questions that or suggestions from the from the first workshop that we had. Antoine actually created several categories. He categorized all the previous inputs into documentation, visualization, easier setup and less maintenance, and engagement. Probably the previous recommendations that we saw could as well be categorized in the same categories. So this is why we are repeating this question here, just to see which part from your opinion requires more attention from the team. So it looks like better documentation and easier setup and maintenance are almost the same, while a visualization is then on the third place and engagement is on the last place in this list. Okay, if we maybe leave one more second, then maybe the structure will change. But anyway, we will post these results somewhere also on our wiki pages. So thank you very much for participating in this Menti. I will now just share a few final slides. This is more of additional recap. So here are again listed the links that you might find useful, like the one where to report the issues related to the documentation, and of course, as Szymon said, if you can be as detailed as possible, that can definitely help the team. And also some mailing lists that were mentioned yesterday and today. The first one is the list that we use in the GÉANT project for our persona team, and this is also used for asking the support from European UNRWAs, particularly if we can assist with any individual use cases of our organizations. And then two lists from the global persona team. Also, Antoine mentioned some of the future persona events. There are in three groups. The first one is from ESnet CI Engineering Lunch and Learn series, and there are 4 presentations available or scheduled now. Here is the link where you can actually find more details about it. Then there is this GPN annual meeting, and Ed and Doug will know more about this persona user workshop. And last but not least, least, before summer is GÉANT TNC conference, and we will have 2 presentations there, one about the graphical user interface that is developed within the team, and also user experience and network performance monitoring for CNaaS. So on behalf of the team that organized this event, we would like to thank to all of participants for that were with us these last 2 days, and more to, of course, to all the authors and presenters that were with us these 2 days. So thank you very much for staying with us and for speaking with us. We would actually like to have more of such events, so we do hope to repeat it on a yearly basis, but for example last year it was not really an option for us, so we cannot commit that it will be, but we will try to do that. Any final thoughts or final comments?
And we hope to see you in person soon.
Absolutely. Yes, that in the next one will be in person. This is also something that we would like to have. So there is a comment from Johan in the chat that a tool like a speed test should be added. And the printed book, I will add those too.
We've discussed adding speed test actually.
Yeah, there is actually an open source implementation of it that will use Ookla's services. And Anno mentioned MTU test, and that again is just a matter of we just need to find a suitable tool to do it. You know, so if there's if somebody has a tool that they like that can do that for us, then great. You know, we sort of do it internally in a couple spots using TracePath, and I suppose we could do that too.
So any comments maybe from Andy? It is actually very strange that Andy did not present anything this time, so we will try to correct it in our future workshops.
Yeah, it's okay. I lingered and I liked listening, so that was good. So no, I think this was great. I think the feedback was good. I think a lot of the items will probably want some follow up in terms of what people are after, like the better documentation and things like that, or people talked about more specific guides. I think kind of getting some insight on what guides in particular people would like to see. I think that would be great. But no, I think it's always great when we get together, and I think this has been a good turnout. So.
Okay, thank you very much. With this, we can conclude the workshop. Antoine, any final comments or thoughts from your side?
No, just a big thank you to every presenters during these 2 days, and to all participants as well. It was very interesting and good to be in this workshop. Yeah.
Thank you all.
Thank you all very much, and have a nice rest of the day.
Thank you. Bye.
Bye.
Bye, everyone.
Thank you. Bye-bye.